Good morning, everyone. So, a very good morning to all of you. So, I hope everybody is doing good. Yeah. So, in the yesterday's class, I have asked you to solve the classroom practice questions from 1 to 7. Out of that, we excluded the sixth question. Okay. So, now let's see. The next topic. So, yesterday we have been discussed about. Yeah. So up to the shear stress distribution we have been discussed in the case of the uniform flow. In the case of the uniform flow. Now we are going to discuss about a new topic known as hydraulically efficient section. After this hydraulically efficient section, then I am going to explain the questions. So no. Hydraulically efficient section. So what is meant by hydraulically efficient section? See, you take any section. Let's take the section plan view. Let's take the plan view as rectangle. And this rectangle is going to be carry a flow. And this rectangle must be having some cross-sectional details. And in the case of the longitudinal section, there must be some bed slope. So whatever the bed slope is nothing but S naught, you know that. In the case of the longitudinal section, so, and this is nothing but a flow of water. And whatever the lining, see, are we going to discuss about rigid boundary canals or mobile boundary canals? Rigid boundary canals, which means you are going to provide some lining, so there must be some roughness. So there must be, for the bed material, there must be some roughness. Yes or no? Then when do you say it's going to be hydraulically efficient section, sir? Now, you see, for a given flow area A, comma, roughness N. What is the meaning of for a given flow area? Which means if there is a cross section and if I fix the flow area and roughness N and bed slope yes no. For a given flow area A, roughness N and bed slope S naught. So if you make sure the flow area constant and bed slope constant and roughness constant, if the given channel is able to carry the maximum discharge, if a given channel is able to carry the maximum discharge, then you are going to say it as a hydraulically efficient section. So for a given flow area, now if channel carries maximum discharge, it is said to be hydraulically efficient. Hydraulically efficient section. So come on, tell me once again. When do you say hydraulically efficient section? If the channel or if the channel section is able to carry the maximum discharge, without change in the flow area. What is meant by flow area over here? B into Y. So the flow area should be constant, and if it is going to be carry the maximum discharge, then you are going to say it as a hydraulically efficient section. So now, how it is going to be happen, sir? How it is going to be happen? So we are discussing about discharge over here, right? Now what is discharge? Q is nothing but A into V. Yes or no? Now I told you for finding the velocity we have Chezy's equation and Manning's equation. But you know which one you have to give preference, Manning's, because of its simplicity in form and moreover empirical data provides experimental results. So from the Manning's, 1 by n into r to the power of 2/3 into s to the power of 1 by 2. So this is the equation. Okay. Now look over here carefully once again. Q is equals to A into 1 by n into, can I write R as A by P whole to the power of 2/3 into s to the power of 1 by 2 into s to the power of 1 by 2. So my dear, here the discharge can be written as the area into velocity, and the velocity again in terms of here. Now you see for a given flow area, which means area is going to be constant. For a given flow area is going to be constant. And for a given roughness, n is also going to be constant. And for a given bed slope, s is also going to be constant. So A constant, n constant, and s is also going to be constant. Then from this, can I write Q directly proportional to 1 by P whole to the power of 2/3, which means I'm going to take all the things as constant. That is the reason why I'm writing this point. Don't ask me, sir, why you are taking other things as constant. If those are constant, and if that channel is going to be carry the maximum discharge, then you are going to call it as a hydraulically efficient section. Now, I hope you can clear this. Q is directly proportional to P or inversely proportional to P. Inversely proportional to P. As a Q is going to be inversely proportional to P, now can I write Q inversely proportional to P? Then for Q maximum, then the wetted perimeter should be minimum. So now the final point is, as the discharge depends upon the wetted perimeter and they are inversely proportional or not. So whenever I can say the maximum discharge, then the wetted perimeter is going to be minimum. Then the wetted perimeter is going to be minimum. Understood or not? So the final conclusion is, so when do you say a channel can carry maximum discharge? Whenever the wetted perimeter is going to be minimum, then the discharge is going to be maximum. So I can write the note point as for discharge to be maximum, wetted perimeter should be minimum. So for the discharge to be maximum, wetted perimeter should be minimum. Now, that wetted perimeter is going to be minimum. See, whenever a variable is going to be maxima or minima, for example, let's take a sine curve. This is going to be a curve, right? A sine curve. Yes. So this is a maximum point, and here it is going to be the minimum point. For anything to be maximum or minimum, this is maximum and minimum curve, right? And if you draw a tangent, what is the slope of the tangent over here? What is the slope over here? 0 degrees. See, you take any variation, whenever there is a maximum point and minimum point, if you draw a tangent, that gives the slope or not. For anything to be maxima or minima, its slope is going to be 0. Its slope is going to be 0. So now what I do is, so I can write for Q to be Q max, then P should be P minimum. So what is P minimum, sir? Then the slope of the wetted perimeter with respect to See, from starting onwards, I was telling you, we are taking rigid boundary canals. Yes. And our main parameter which varies is depth of flow. So you are going to vary the wetted perimeter. Means what is the meaning of dp by dy? Variation of wetted perimeter with respect to depth. Variation of wetted perimeter with respect to depth. This is simply known as a slope. Slope, my dear. Okay. So if you draw the variation with respect to p and y, then the slope dp by dy is equals to 0. For anything to be maximum or minimum, the slope is going to be 0. Okay. Now I hope you got the actual reason behind when do you say maximum discharge. Let's apply this one for all the channels. Let's say rectangle first of all. In the case of the rectangle, give me a minute please. No. Okay, fine. So the meaning of dp by dy is equals to 0 means see, if you want to make sure anything to be maximum or minimum, the variation of that parameter with respect to the variable. What is the variable here? Y. So that parameter is going to be weighted perimeter. So for that is a basic mathematics. I hope in mathematics you came across the maxima or minima chapters. So for anything to be maximum or minimum, its a first derivative is going to be 0. Its a first derivative is going to be 0. So differentiation of the weighted perimeter with the y, first derivative is going to be 0. Now come on to the rectangle. So in the case of the rectangle, let's say this is a rectangle of width b and depth as a y. Of width b and depth as a y. Now, what is area? Area of the rectangle is going to be b into y. And what about weighted perimeter? B plus 2y. Listen to me carefully. See, I know these are the cross-sectional details. Yes. And now, if you observe, I want to make sure for discharge to be maximum, weighted perimeter is going to be minimum. Now, everybody, you see the weighted perimeter is a function of how many parameters here? In this cross-sectional details, there are two details. Width is there and depth is there. Width is there and depth is there. See, the area should be constant. Now, think and say, how come I say area is going to be constant? See, this is area. I can say for a given flow area, you have to make sure area is going to be constant. Okay. Now, this is a rectangle. this is a rectangle. If I make sure area is equals to 10 meters square, let's say area is equals to 10 meters square. And if I want to make sure this area has 10 meters square, then b into y is equals to 10. Okay, if I change y, do you think b is going to be constant? No. So what may be the possibilities of b and y for 10? What may be the possibilities of b and y so that the area is going to be 10? We can write 2 into 5 is equals to 10, 5 into 2 is equals to 10, 4 into 2.5 is equals to 10. Yes or no? Or 2.5 into 4 is equals to 10. Or 3.33 into 3.33 into equals to 10. See, what I want to focus over here is, if you want to make sure area as a constant, then the product of b into y, if the depth changes, then the width is also going to be changes. If the depth changes, then the width is also going to be changes. So now the point over here is, see, for constant area, if width changes, depth is also going to be changes. Okay, then the p is a function of both b and y. B is a variable and y is also a variable. So there are two variables. In an equation, if there are two variables means which are continuously varying. You cannot differentiate, right? So what I'm going to do is, I'm going to convert either b in terms of y or y in terms of b. Either b in terms of y or y in terms of b. How, sir? Now, sir, you see, can I write this b as a by y? Can I write this b as a by y? Now, you please substitute this b over here. Then vector parameter p is equals to a by y plus 2y. So, for a given flow area, Q becomes Q maximum when weighted parameter is minimum. So dp by dy is equals to 0. See, my dear students are here. Now, if you observe in this equation, you please look over the P. In the P, area is going to be constant. Yes or no? Area is going to be constant. So if area is going to be constant, P is a function of whom now? Y. Then for anything to be maximum or minimum, its a first derivative is going to be 0. So now what is the first derivative over here, please? So the first derivative, the variable parameter is P, variable over here is nothing but dp by dy is equals to. Now come on, tell me, area is going to be constant or not? So what is 1 by y? What is 1 by y? So integral of 1 by y. Tell me. So the integral of 1 by y is nothing but minus 1 by y square. Yes or no? Which means minus a by y square plus 2y. So it's not integral, it's a differentiation. So differentiation of 1 by y is equals to minus 1 by y square plus differentiation of y is equals to 1. So is equals to 0. Minus a by y square plus 2 is equals to 0. Then can we write this minus to the other side? Then a by y square is equals to 2. A is equals to 2y square. Then what is the area? By. By is equals to 2y square. Then from this, can I write b is equals to 2y? So now, my dear, can you tell me what is the condition required to create maximum discharge? In the case of the rectangle, for a given flow area, if you want to take a maximum discharge, then what is the condition? The condition is whatever the top width, what is the top width over here? The top width is equals to b. Whatever the top width is equals to 2 times of the depth of flow. Top width is equals to 2 times of the depth of flow. So whenever the width is going to be 2 times of the depth of flow, keep that in your mind. Then the weighted perimeter is going to be minimum, and that channel is going to be carry the maximum discharge. I hope you understood. So This is the condition required to create the maximum discharge in the case of whom? In the case of the rectangle. If this is the condition, then how come the hydraulic depth and hydraulic radius is going to be changes? Hydraulic depth and hydraulic radius is going to be changes. Okay. So the hydraulic depth D is equals to A by T. What is A? By T B. So still the D value is equals to Y only. Still the D value is going to be Y. So now can I say whether the rectangular section is a normal rectangle or whatever the efficient rectangle or wide rectangle or any other rectangle, as long as it is rectangle, what is its average depth? Y. But what about R value, please? R value here, see, if you know this B is equals to 2Y, right? Then what is R value? A by P. A by P means by B plus 2Y. So now can I write a B as a 2Y? Then 2Y into Y, 2Y square by B plus 2Y, 4Y. So can I write the R value is equals to Y by 2. The R value is equals to Y by 2. So finally, in the case of the hydraulically efficient rectangle, if you want to make sure the rectangle is hydraulically efficient, what is the meaning of hydraulically efficient? Discharge to be maximum. Then wetted perimeter is going to be minimum. When the wetted perimeter is going to be minimum, then what is the condition required for getting that? In the top width, I can write this one. The top width is equals to 2 times of sides. What is the side? The side is nothing but Y. Side or depth of flow both are same or not? So 2 times of the sides. So this is nothing but sides, right? So this is also going to be Y. Okay. I hope you understood this. Sir, now you can ask me a question. Sir, you are saying area is going to be constant and B and Y both are variables, na? Yes or no? Yes or no? Yes. So Y and B both are variables, but you are differentiating with respect to Y only. Why cannot you differentiate with respect to B? I can say R. Now again, this time area is equals to B into Y, right? This time I'll write Y in terms of B. Y in terms of B. So then what is P value? B plus 2Y. Yes or no? What is the wetted perimeter? B plus 2Y. And in this wetted perimeter, how many variables are there? Width is a variable and depth is also going to be the variable. Both width changes and depth changes. If both are changes, you cannot differentiate directly. So what I do is, now this time I'll write Y in terms of B. If I write Y in terms of B, B plus 2 into A by B. Now my dear, what is A? Flow area. That is going to be constant or not? And what is B? That is a variable. So how many variables are there now? Only one variable. And when do you say maxima or minima? If the differentiation of this wetted perimeter with respect to what is a variable now? B, dP by dP. See, it's not about dP by dy only. It's about whatever the parameter you are taking, that differentiation or first derivative with respect to the variable. What is the variable here? B. Now, can you please find out dP by dB? So, dP by dB, differentiation of B, that is going to be 1 plus 2 into area is going to be constant, right? So, minus here 1 by B, which means, can I write as, okay, fine, minus A by B square is equals to 0. Minus A by B square is equals to 0. So let's take this minus to the other side. Then 2A by B square is equals to 1. Then can I write 2A is nothing but 2A is nothing but B square. And what is 2A? 2 into area by into B square. 1b gets cancelled. 1b gets cancelled. Then what is the final condition b is equals to 2y, which means the top width is equals to 2 times of the sides. So you can observe that both the relations are going to be same. Yes or no? Whether you differentiate with y or whether you differentiate with the width, you are going to end up with the same conditions. And what is that condition? The top width is equals to 2 times of sides. I hope you understood the differentiation over here, and you got the conditions. So in examination, so they simply gave you the hydraulic efficient rectangular section. If they mention you the hydraulically efficient rectangular section, then simply the top width b is equals to 2 times of the side slopes. So if you remember this condition, right, you can find out any other conditions. I hope you got these values. Now let's see, for better understanding, let me go with the next triangular section. Next, coming to the triangle. So this is a triangular section, and let's take the depth of flow in the triangle is y, and side slope is nothing but 1 vertical to m horizontal. 1 vertical to m horizontal. Okay. And what is the area of the triangle? Area my square. You must have to remember. So by this time, this is the 5th day, and we have done the channel geometry on the 2nd day. I hope you people have came across those channel geometry details. Now, what is the weighted perimeter, please? What is the weighted perimeter? 2y into root of 1 plus m square. The weighted perimeter is going to be 2y into root of 1 plus m square. Okay. Now, again, this p, I want to find out at constant area, right? So area should be constant. When area is going to be constant, then m and y both are going to be values. Yes or no? So you say, you know that whether you differentiate with m or y, you end up with the same answer. Yes or no? You end up with the same answer. So now this time what I do is I'll write this y in terms of m. See, earlier I have written you see b in terms of y, and I showed this y in terms of b. We ended with the same answer or not? So similarly, now I am going to write. It's up to you, my dear. It's up to you. Either you can write m in terms of y and you can substitute over here, or you can write y in terms of m, you can substitute over here. So y, if you write y, then this is going to be root of a by m. Yes. So now what is p here? 2 into root a into root of 1 plus m square by m square. I hope you can understand this, what I have written, because it is going to be root m, right? Yes. So this is going to be root m, and I'm sorry. Yeah. It is going to be root m. So y, if you substitute root of a by root m, root a by root m, root of 1 plus m square by root m. Yes. And you can write this further as p is equals to 2 root a into root of 1 by m plus m. Root of 1 by m plus m. Now differentiate. See, a is going to be constant and m is the only variable. Now differentiate the weighted perimeter with the variable dp by dm. So 2 root a, this is going to be constant, into 1 by, see, root x. What is the differentiation of root x? What is the differentiation of root x? 1 by 2 root x are not. So differentiation of this root, which is going to be 1 by 2 into root of 1 by m plus m into, now differentiation of the inside parameter. Yes or no? What is root a? 1 by 2 root a into dA by dy. Yes or no? So you have to differentiate this one 1 by 2 root x into differentiation of the x. What is this differentiation now? Minus 1 by m square plus 1 is equals to 0. Minus 1 by m square plus 1 is equals to 0. Now you send every part of this one to the other side. You send every part to the other side. Then it is going to be 0 or not. Then I can write simply minus 1 by m square plus 1 is equals to 0. And from this, take to the negative other side, 1 by m square. So m square is equals to 1. Then what is m value? 1. What is m value? M value is equals to 1. So when do you say that m is equals to 1? Have you remember anything? When do you say that m value is equals to 1? So when m is equals to 1, you know this is nothing but my. Yes. So when do you say m is equals to 1? When the theta, if this is theta, then the tan theta is equals to my by y. Y gets cancelled. So when m is equals to 1, then theta is equals to 45 degrees. So I hope you remember, whenever the m is equals to 1, can I say it as a symmetrical triangle with apex angle 90 degrees? Yes. So I have already given you the symmetrical triangle with apex angle 90 degrees in the starting cases. Yes or no? So my dear student, now I am concluding here as, if you want to make sure that triangle is a hydraulically efficient triangle, then that triangle should be a symmetrical triangle with apex angle 90 degrees. With apex angle 90 degrees. Because one side theta 45, other side also 45. So now the note point is symmetrical triangle with apex angle 90 degrees is hydraulically efficient triangular section. Hydraulically efficient triangular section. Okay, so now if it is going to be a hydraulically efficient triangular section, you know that the hydraulic radius is nothing but y by 2 root 2. You know, have you, means we have been discussed about all those details earlier in the starting itself. Yes. So for symmetrical triangle with apex angle 90 degrees, what are the details? So I have already given this one, and what we need to remember here is the R value. What is R value? Y by 2 root 2. So in simple words, you just remember symmetrical triangle with apex angle 90 degrees is nothing but a hydraulically efficient triangle. I hope you understood. Now, so first one, rectangle. What is the condition for the rectangle? Top width is equals to 2 times of the sides. And what about the triangle? Symmetrical triangle with apex angle 90 degrees is going to be hydraulically efficient channel. Now, let's come to the next one. Third one. Trapezoidal section. Trapezoidal section. So in the case of the trapezoidal section, in trapezoidal section, this is the water surface, depth of flow y, width b, and side slope 1 vertical to m horizontal. So now, my dear, how many cross-sectional details are there here? See, in the case of the rectangle, the cross-section details are B and Y, only two. In triangle, the cross-section details are M and Y, only two. But in the case of the trapezoidal, B is there, Y is there, and M is there. B is there, Y is there, and M is there. So can you write down the area please here? What is area please? You know the area of the trapezoidal as area of rectangle plus triangle. So area of rectangle BY plus triangle MY square. And what about the weighted perimeter please? What about the weighted perimeter? The weighted perimeter is nothing but the top means base width B plus sides 2y into root of 1 plus m square. Again, the same way, the same. What I am going to do is area is constant. Yes or no? So when the area is going to be constant, then you see how many variables are there here? B is a variable, M is a variable, Y is a variable. Three variables are there. Means three cross-section details are there. For constant, for area to be constant, think and say, for area to be constant, do you think out of these three, only one should vary, or two should vary, or all the three should vary? Any two of these two variables can vary, that's it. If only one variable is going to be changes and others are constant, then area will definitely change. Okay, so for area to be constant, at least the two variables means two parameters should vary, either BM or MY or BY, and other can be constant. So I want to make sure area is constant. If I want to make sure area is constant, out of these three cross-sectional details, any two should vary. Any two should vary. So now let me write down this. Let's take B is a variable. So I told you out of three, one should be, means two should be the variables. Yes or no? Let's take B is variable, and I'm writing the B in terms of Y's. So please look over here. I won't write the Y, or I won't write the B, please. So here, can I write this B as yes, A by Y, because divided with the Y on both sides, A by Y minus MY. Can I write like this? Divided with Y on both sides, A by Y is equals to B plus MY. So now, what is the weighted perimeter? You know the weighted perimeter is nothing but B plus 2Y into root of 1 plus m square. Now substitute P in terms of B. Now P is equals to, what is B? A by Y minus MY plus 2Y into root of 1 plus m square. Okay, so listen my dear, already I took the B as a variable. Just now I mentioned you, if area wants to be constant, any two of these cross-sectional details can be varies. Already I have taken width is going to be varies. So I am writing width in terms of depth. Okay. Now I have two more other cross-sectional details, M and Y. Already one is variable. And out of these two, Y and M, I can take one thing as a variable, other thing as constant. One thing as variable, other thing as a constant. So now what I'm going to do is I'll take this a condition. Still, you see, the width is a function of whom? M and Y. Still, width is a function of M and Y. Can you differentiate it directly? No. Now, case A. Assume if M is constant. If M is constant. If M is going to be constant, the only variable is going to be Y, right? Already B is variable. Keep that in your mind. Now, if I keep M as constant, what is the only other variable? Y, right? Now differentiate the weighted perimeter with respect to Y. Differentiate the weighted perimeter with respect to Y. So dp by dy is equals to, come on, the only variable is Y, right? So A by Y minus A by Y square minus My, as M is going to be constant. So differentiation of Y 1 plus 2 into root of 1 plus m square. So M is going to be constant, right? Again 2 into root of 1 plus n square is equals to 0. Now you take this minus terms to the other side, then a by y square plus m is equals to 2 into root of 1 plus m square. Take this y square to the other side by taking the denominator, then a plus, I can write this one as my square is nothing but 2y square into root of 1 plus m square, because you please change this y square to the other side. So 2y square into root of 1 plus m square. Now, what is area, please? Please write down the area once again here. In the case of the area, so what is area, please? By plus my square plus my square is nothing but 2y square into root of 1 plus m square. 2y square into root of 1 plus m square. So now, my dear, what I want to look over here is, you observe, can you please cancel down y? Yes or no? So you can simply cancel down 1y. Yes. Now if I rewrite this one, can I write as b plus 2my? What is this b plus 2my? B plus my plus my. 2my is equals to 2y into root of 1 plus m square. So the final condition here is, what is the final condition over here? So b plus 2my is equals to 2y into root of 1 plus m square. Give me a minute, please. Please have a look. Meanwhile, I'll come with an I'm sorry. From morning onwards, I'm getting the side abdominal pain. So there's a reason why I'm taking intermittent breaks. Still, I'm having a pain in the sides. Let's see how it goes. So now b plus 2my is equals to 2y into root of 1 plus m square. So whatever the top width here, you see what is mean by b plus 2my. In the case of the trapezoidal channel, the top width t is equals to b plus 2my. Yes or no? So the top width t is equals to 2 times of the y into root of 1 plus m square is nothing but side slope. Y into root of 1 plus m square is nothing but the side slope. So as it is going to be 1 plus y into root of 1 plus m square, I can write it as a 2 times of side slope. 2 times of side slope. So now the top width is equals to 2 times of the side slope. In the case of the rectangle, you see, in the case of the rectangle, what is the side? Side is nothing but the vertical side. Yes or no? See, b plus b is equals to 2y. And in the case of the trapezoidal, b plus 2my is equals to 2y into root of 1 plus m square. What is the difference between the rectangle and trapezoidal? Think and say. What is the difference between the rectangle and trapezoidal, my dear? In the case of the rectangle, the sides are vertical. When the sides are vertical, then what is m value? 0. Yes or no? In the case of the rectangle, the sides are going to be vertical. So when the sides are going to be vertical, the side slope m is equals to 0, because this is one vertical to m horizontal. If this inclined is going to be becomes like a vertical, then m is equals to 0. If you simply keep m value 0, come on, tell me in this equation. In this equation, if I simply keep m as 0, what happens? If m 0, then b is equals to 2y. See, if m0, this portion 2my is equals to 0, b is equals to 2y into root of 1 plus m square. M is equals to 0 means root 1. B is equals to 2y. That's it. So the difference between the rectangle and trapezoidal is this side slope. If the sides are going to be vertical, that is going to be rectangle. Then m is equals to 0. In both the cases, this is going to be the top width is equals to 2 times of sides, and here it is going to be top width is equals to 2 sides or 2 times of side slope. I hope you came across this condition somewhere, right? You came across this condition somewhere. You just go back. Yes. So what is the special condition I mentioned in the trapezoidal section? Trapezoidal section as a half of the regular hexagon. Yes or no? As a trapezoid is a half of regular hexagon, then you see what is the top width over here, please? What is the top width? I made sure these sides are going to be same. So that what is the top width over here? The top width is nothing but 2 times of I, which means 2 times of a side slope. Yes or no? So whenever the top width is equals to 2 times of side slope, then that trapezoidal section is going to be act as a half of regular hexagon. The trapezoidal section is going to be act as half of regular hexagon. Yes. So now in this case over here, so whenever I say the top width is equal to 2 times of side slope, this is going to be half of regular hexagon. This is if m is equals to constant. Now you may ask a question, Are sir, why you take m is constant? Can I take y as constant? If I take y as constant, then what is the variable m? And if I get the same relation, sir, let's see. Condition B. If y is constant, if y is a constant, yeah. So if y is going to be constant, then which is going to be the variable? M is going to be the variable. Then dp by dm is equals to, come on, you see dp by dm. What is p? A by y. In this there is no m term. So differentiation of constant is going to be 0. 0 minus my minus y plus, you see this is going to be root, right? Plus 2y into root of 1 plus m square, 1 by 2 into root of 1 plus m square into inside 1 constant 0 plus 2m is equals to 0. So this is going to be the differentiation. So 2y into root x, 1 by 2 root x into differentiation of that x means 1 plus m square, 0 plus m square means 2m. Now you take this y to the other side. You take to the other side, then here 2 will get cancelled. So can I write 2m y by root of 1 plus m square is equals to y. Y will get cancelled. Then 2m is equals to root of 1 plus m square, and root of, if it comes to the other side, that is going to be the 2m square. So then 4m square is equals to 1 plus m square. You send the m square to the other side, 3m square is equals to 1, m square is equals to 1 by 3. Then m is equals to 1 by root 3. The side slope m is equals to 1 by root 3. So if I take y as constant, the condition that should be required is 1 by root 3. When do you say m is equals to 1 by root 3, sir? Sir, this is a side slope, sir. 1 vertical to m horizontal. Let's take this angle as a theta. Now, what is the tan theta here? Tan theta is nothing but 1 by m is equals to root 3. Then what is theta value here? 60 degrees, right? Whenever the 120 degrees. Whenever the inner angle is 120 degrees, now this trapezoidal section can be said as a regular hexagon or not? Yes. See, this is a one condition for the regular hexagon, or this is a one condition for the regular hexagon. Both are going to be there. So now just go back again, once again. Yes. You see, whenever I say it is going to be regular hexagon, what are the conditions I said to you? Top width is equals to 2 times of side slopes, or m is equals to how much? 1 by root 3. Now, from the conditions, what I got here is the same thing, right? Either m is equals to 1 by root 3 or this condition. Both are represents the half of a regular hexagon. Both are represents the half of regular hexagon. So now the note point is half of regular hexagon acts as hydraulically efficient trapezoidal section. So this is the node point. Half of so now, sir, you can go with a now y and you can take b. See, you can reiterate where whatever you reiterate, you are going to be end up with the two conditions. One is top width is equals to 2 times of slopes. So top width is equals to 2 times of side slope, and m is equals to 1 by root 3. If this is the case, then the cross sectional details are a is equals to root 3y square, and hydraulic depth is equals to 3 by 4y, and hydraulic radius is equals to y by 2. So if you have any doubts, you please go through this condition in page number . 29. I have clearly explained these conditions. So what is top width and what is area, root 3 y square, and root 3 y square, wetted perimeter, hydraulic depth, and hydraulic radius. I hope you understood this. So that's about the trapezoidal section. Please have a look once again. And then we go for the next sections. Yes. So now, see, so far and so good. I have given you the conditions. So I hope you understood what is the difference between the trapezoidal section and rectangular section. In the case of the rectangular section, the sides are vertical. When the sides are vertical, then m is equals to 0. If the sides are vertical, then m is equals to 0. And in the case of trapezoidal, as there are sides, there is m. So if you keep m 0, then the conditions is going to be same as the rectangle, right? And if you see one more thing, in the case of the efficient rectangle, r is equals to y by 2. And in the case of the trapezoidal also, r is equals to y by 2. So now, let me give you one special condition over here. So the special condition is let's say this is a unsymmetrical trapezoidal section. There is an unsymmetrical trapezoidal section. So in the case of the unsymmetrical trapezoidal section, now if this is the water level and you know that whatever depth of flow, the depth of flow is y and side slope is 1 vertical to m horizontal and base width is going to be b. Now does this section just looks like a intermediate section between rectangle and the triangle? Between rectangle and the triangle, yes or no? See, in the case of the rectangle, both sides are vertical, so I can keep the total m value as a 0. Now here you see this is my in the case of the top width. You please observe carefully. This is my, this is b, and this is going to be my. Yes or no? In the case of the horizontal, means in the case of the rectangle, as both sides m is equals to 0, this value 0, this value 0, so the top width is going to be b. Now, if you observe here also, in this special condition, now the same condition is going to be applied as here. You solve this one. If you solve, then the top width for efficient condition, the top width is equals to, now the side, one side is going to be vertical side, yes or no? Side plus the other one is going to be a side slope. Side slope. I hope you observe. See, in rectangle what I said, top width is equals to side plus a side, means 2 times of sides. In the case of trapezoidal, top width is equals to side slope, because in the case of trapezoidal both are going to be inclined, so 2 times of I. Now I can write this one as a further. vertical side plus inclined side. Come and tell me, what is the top width over here? So this is B and this is going to be my. B plus my is equals to vertical side y plus y into root of 1 plus m square. That's it. And if you want to go for rectangle, you keep m is equals to 0. If you keep m 0, this is also going to be 0. And this here b is equals to 2y. So in simple words, for all the rectangle, trapezoidal and unsymmetrical trapezoidal, the condition of the efficiency is going to be same. What is that? The top width is equals to side plus a side. If those are vertical, y plus y. If those are inclined, 2y into root of 1 plus m square. One side vertical, y, other side inclined, y into root of 1 plus m square. And the hydraulic radius is equals to y by 2. And the hydraulic radius is equals to y by 2. If you have any doubt now, then you just follow whatever the procedure I have approached over here for the trapezoidal. You just follow that. You are going to end up with the same condition. If you don't end up with the same condition, then you come to me, then I discuss that. But I hope you understood the logic behind this. The logic is simply this m. You keep m0 rectangle. You keep both the m's. If you want to make sure this is also inclined, then you have to add plus my. Okay. So now, come to the note point. So in the case of the note point now, what I want to discuss is, so far and so good, whatever the channels we have been discussed, rectangle, triangle, trapezoidal. What is the common thing in all the three channels? What is the common thing in all the three channels? The common thing in all the three channels is all the sides of these channels are diverging at top. If the sides are going to be diverges at the top, then we call it as a type 1 channels. Then we call it as type 1 channels. So what do you mean by type 1 channel? Type 1 channels. So the meaning of type 1 channels is the channels whose sides are not going to be converges at the top. Channels whose sides do not converges at the top. Do not converges at the top. Okay. So this is nothing but the type 1 channel. And sir, why you are discussing this now? Because whatever the discussion I have made is for the type 1 channel. And now, whenever the sides are going to be converges at top, which means circular sections, then we call it as a type 2 channels. Type 2 channels. So what is nothing but the type 2 channels? You see, this is a circular section whose tops are going to be converges at the top, means whose sides are converges at top. And this is a rectangular section. So this is a triangular section whose apex point is pointing towards top or bottom? Top. So this is also a triangle, but apex is pointing towards top, and this is the water level. Yes, sir. So whenever the sides are going to be converges at the top, sides converges at the top, then we call it as a type 2 channels. If I say in other words, the closed mediums are type 2 channels and open mediums are type 1 channels. So far and so good, our analysis is going to be based upon this one. Yes or no? Now, if it is going to be a type 2 channel, the last one is going to be circular, right? Now coming to the type 2 channels. In the case of the type 2 channels, means circular section. In the case of the type 2 channel, so circular section. See, some of the people are asking, sir, explain the special condition again. My dear, whatever the top width, my dear, you see, can I resolve this one into, now everybody please observe. Can I resolve this one into b plus my plus my is equals to, this is 2y into root of 1 plus m square or not? Y into root of 1 plus m square plus y into root of 1 plus m square. Can I resolve this one? Can I resolve this one into b plus 2my is nothing but b plus my is equals to y into root of 1 plus m square plus y into root of 1 plus m square. Yes or no? What is this my? This is my. This is my. What is this y into root of 1 plus m square? This is side slope. That is the reason why we write is a 2 times of side slope r naught. Now, you see, if I keep one side as vertical, you see, this is going to be the vertical r naught. Here m is equals to 0. On one side is going to be vertical. If I write one side as vertical, then what I do is on one side m is equals to 0. On one side m is equals to 0. If I write one as on one side m is equals to 0, then what is this value? b plus my, and as m is equals to 0, then root of 1 y plus y into root of 1 plus m square. When one side m is equals to 0, but if you go for the triangle, in the case of the triangle, on both sides m is equals to 0, right? What is the meaning of m0? There is no horizontal in the vertical direction, right? So if both m is equals to 0, then if this m is 0 and if this m is also going to be 0, then this is also going to be cancelled out or not. Then what is the condition you are going to see? The condition you are going to see is nothing but b plus 2y. So I'm just splitting this, and if there is a vertical side, on that side you keep m0. Still, if you don't understand, you please go through the procedure. So now coming to the circular sections. In the case of the circular section, sir, how you wrote directly r is equals to y by 2? I did not write it as r equals to y by 2. You please substitute, Nana. You please apply this condition. You see, for the trapezoidal, that's what I mentioned here. Yes. So for the trapezoidal, the condition, this is the condition. What is r value? Y by 2. For the rectangle, what is r value? Y by 2. What is r value? Y by 2. See, you have to understand the common thing here is, for rectangle, trapezoidal, unsymmetrical trapezoidal, the top width is nothing but side, 2 times of sides, or 2 times of side slopes, or side plus the side slope. So the condition is going to be similar in all the 3 cases. And if you substitute, then the r value is going to be y by 2 only. If you have any doubt, I'm telling you, instead of asking me the question why you have written r is equals to y by 2, you please apply this condition in hydraulic radius, then I'm telling you for sure you are going to get the answer. Please refer a reference book for FM2. The Open Channel Flow by K. Subramanya. Open Channel Flow by K. Subramanya, that is the best book for the open channel flow. and that's the only one textbook which is exclusively for open channel flow, because you take any other textbook, Modi and Seth or Bansal or any other textbook, so they have taken the open channel flow as a small part in the fluid mechanics itself. So very few textbooks are available for the open channel flow exclusively, and out of that, the topmost is going to be K. Subramania. And for hydrology also, you can follow the same textbook. Means Subramania, he's a very good author regarding to the hydraulics. So you can follow the textbook. Is reading textbooks required, sir, or your notes is enough? At first, my notes is enough. And if you still have a time, if you still possess a time, then only you go to the textbook. Now coming to the circular section. In the case of the circular section, you know, when do you say the circular section is going to be open channel flow? If the flow runs partially. If the flow is going to be runs partially, then we say it as a circular section. Okay. So now, my dear, if this is a depth of flow, as y. If this is going to be the depth of flow as y, so for the circular section, the depth of flow is going to be y. And now, is type 2 channel or type 1 channel? This is a type 2 channel. So type 2 channels, the common point in type 1 channel is rectangle. I took area as constant. Triangle, I took area as constant. Trapezoidal, I took area as constant. But in the case of the circular section, for type 2 channels, flow area cannot be constant. Why? Because I hope you remember, see, if this is center, now with respect to center, this is a sector or not, and whatever the angle made by this is going to be 2 theta now. Whatever the angle is going to be 2 theta. Earlier I have given a partial one, now I am taking more than half, right? So now see the same equations. Earlier I have given these equations, r square by 2 into 2 theta minus sine 2 theta, and weighted perimeter is nothing but 2r theta. I hope you remember this one. Now everybody have a look. We are going to differentiate with respect to PR. You know R is going to be constant. You know R is going to be constant because R depends upon whom? Dia of a circular section. R depends upon the dia of the circular section. So R is going to be constant. In the case of this one, area is a function of whom? Theta. Area is a function of theta. If theta changes, area is going to be changes, and the weighted perimeter is also going to be changes. If theta changes, area is going to be changes, and weighted perimeter is also going to be changes. So in the type 1 channels, we are going to see area as constant. So there, if area is going to be constant, I am going to take all the parameters are constant. But in circular channels or type 2 channels, area is not going to be constant. When area is not going to be constant, there exists 2 depths. There exists 2 depths. So for efficiency conditions, there exists 2 depths. Sir, why you are saying that there exists 2 depths, sir? Now you see, you observe. Let me write down that Q is equals to A into V. Yes or no? Now A into 1 by N into what is R? A by P whole to the power of 2/3 S to the power of 1 by 2. Okay. So can I write directly Q directly proportional to A to the power of 5 by 3 by P to the power of 2 by 3? P to the power of 2 by 3? Yes. Okay. Now this is a discharge. Similarly, you write down for velocity. For velocity, V is nothing but 1 by N into R to the power of 2/3 into S to the power of 1 by 2. So can I write V directly proportional to A to the power of 2/3 by P to the power of 2/3. And you know that whatever the velocity we take is the average velocity R naught. Yes. The difference between type 1 and type 2. Now, observe here clearly. In rectangle, triangle and trapezoidal, I took area as constant. Yes or no? When I take area as constant, listen, if I take area as constant, discharge is directly proportional to whom? P to the power of 2/3. P to the power of 2/3. The discharges are inversely proportional to P to the power of 2/3 when I take area constant. If I take area constant, velocity is also directly proportional to P to the power of 2/3. When I take area is going to be constant, for maximum discharge and for maximum average velocity, the conditions are same, except R naught. If I take area is going to be constant, whatever the maximum discharge is nothing but the maximum average velocity. In simple words, area is going to be constant, so maximum discharge is going to be attained, maximum average velocity is also going to be attained, and the condition is going to be same. So only one depth is going to be exist. Only one depth is going to be exist. But just now I mentioned you, in the case of the type 2 channels, flow area cannot be constant. Because we are going to make sure, as is a closed channel, right? This is a closed channel. You have to prefix the dia of the circular section, which means R is constant, then area is a function of whom? Area is a function of theta. And if Y is going to be changes, then the theta is also going to be changes. So now for maximum discharge condition, for maximum discharge condition, so dq by now d theta, because this is in the form of whom? Theta. So now I cannot take it as a weighted perimeter itself, because here only weighted perimeter is variable. No, here area and weighted perimeter both are variables. So then d by d theta of a to the power of 5/3 by p to the power of 2/3. A to the power of 5/3 by p to the power of 2/3. Similarly, for maximum average velocity, then dv by d theta is equals to d by d theta of a to the power of 2/3. Directly I can write as a by p, right? Because I can remove the powers directly. I can remove the powers, right? 2 to the power of 3, 2 to the power of 3, both powers are same. So I can remove that, b directly proportional to a by p. D by d theta of a by p. So come on, my dear. You tell me now, for maximum discharge and for maximum average velocity, if you differentiate, are you going to end up with same condition? Every time I differentiate, I am going to come up with some conditions, right? This is the conditions for the type 1 channels. But are you going to end up with the same condition? No. No. For maximum discharge, after solving, for maximum discharge, after solving, the y value is equals to 93 times of d, where d is the dia of a circular section. Where d is the dia of the circular section, and r value is equals to 0.29 times of d. So means if you are going to solve this, if you differentiate this one, I am not going to differentiate. So because you don't require any differentiation, and especially for gate point of view, this is not at all important. And in ESE mains, type 2 channels are important. Mains, for not prelims also, in mains. So in mains exclusively, I am going to discuss about the type 2 channels. But for prelims and for gate point of view, you don't need to go too much into the type 2 channels. You have to understand about the type 1 channels only. So now, if you differentiate this, you are going to end up with the results for maximum discharge. What is the depth? 0.93d, which means if in a circular section, if the flow passes 93% of the dia of the circular section, then you can allow the maximum discharge. And for maximum average velocity condition, if you solve, you will end up with a 0.89D and R value is equals to 0.3D. Let me check once. I have to look over this Y value. Let me check once. This is a 0.81D. Sorry. Is 0.81D. So these are the conditions for the maximum discharge and for maximum average velocity. And you need to remember these values because in ESC prelims they may ask you about this maximum discharge. What is a hydraulic radius? See, don't worry about this, how these came, because just by simple derivations, but it takes a lot of time. We don't require the derivations, but wherever it is required, I have already given those derivations. So that's about the discharge, means hydraulically efficient conditions. So that's why you see here there is a one depth and here is going to be one depth. For maximum discharge one depth, for maximum average velocity one depth. So that's the reason why for efficiency conditions there exists two depths in type 2 channels. So keep that in your mind. Sir, how come you cancel the power, sir? I'm not cancelling powers, my dear. When you are going to differentiate, see, you're going to look over the proportionality, right? Both powers are same. That's basic mathematics. So don't ask me the doubts in the mathematics. Even I am not too good with the mathematics. I know the basic differentiation and integration. And even I have failed in M1 while I was doing my MTech. Not failed, but I get very, very less marks. So don't ask me too much doubts in the mathematics. I know just basic integrations and differentiations. Who said velocity came constant? I did not set any velocity constant over here. So that's about the efficiency conditions, and these efficiency conditions are very important. You have to remember that. So what is the maximum discharge if it is said to be? Yes. And coming to the last, I'm concluding this topic, hydraulically efficient. Note, efficiency versus economical section. I hope in the starting of this chapters, while I was discussing about the various cross-section of shapes, various cross-section means various shapes of the cross-sections. I said you there are different type of shapes, and I said you which one is going to be the economical. Which is economical? Please tell me. So semicircular section is going to be the most economical section. I told you there. Why? It has least weighted perimeter. Yes or no? Now in the case of the efficiency also, I told you when you say the channel is going to be efficient, if the discharge is maximum, when does the discharge is maximum? When the weighted perimeter is going to be minimum. So for a given flow area, if weighted perimeter is minimum, it is said to be economical and efficient section. Economical and efficient section. But you know that both are not going to be same. See, efficiency means maximum discharge and economical means the cost is going to be less. So efficiency deals with maximum discharge And economical deals with minimum cost of lining. And you know that semicircular section is going to be the most efficient and economical section because it has very least pitted perimeter. Semi-circular section is economical and efficient, but you know, in practical the design is going to be not suitable. So what we prefer? We prefer the trapezoidal section. So trapezoidal section is going to be very good both in terms of efficiency and in economical conditions. So that's the reason why in most cases we observe the trapezoidal conditions instead of semicircle. Okay. So I hope you understood these concepts clearly. I hope you people are able to follow my classes. So if you have any problem with my class, you can let me know. I hope you people are enjoying the classes the same way that you enjoyed the geotech. Yeah. So I hope you completed, right? Yes. Now let's see some questions based upon this one. So with this we have completed the uniform flow and hydraulical efficient sections. This is chapter number 2. Chapter number 1 completed, chapter number 2 completed. Yesterday I have given you some topics, right? So in the topics, hydraulical efficient sections comes under uniform flow conditions only. So yeah, in examination, if they give semicircular and trapezoidal sections, which of the following is most economical, you opt for semicircular only. You don't opt for the trapezoidal. But if they ask which one is more preferable in the practical situations, then you say trapezoidal. And one more thing, I want to say a lot of people, so I want to give some suggestions regarding to the examination once again. Right now we're in August, and I hope the people who I have taken the geotechnical engineering in around June, I think so, or in May, right? Yes, in May. In around May 5th to or April 28th to June first week I have taken. Yes. So there and then itself I said one point, and now today also I am going to say one more point. See, the most of the questions that I get by means of mails are while I am taking classes, whether it is an online class or offline class or recording classes. So most of the questions that people are asking is, does 5 months or 6 months or 2 months or 3 months are enough for the preparation and to get a very good gate rank? See, I told you, I have studied just 2 to 3 months. Effectively, I just studied 2 to 3 months only. And this is the actual time when I started my preparation. In 2013, August 15th, after August 15th only, means after the Independence Day, I have studied in my previous classes also. So on the August 15th, I started my preparation in 2013 for GATE. And I got a GATE rank of 650. So if I can start in August and I can get a rank of 650, and at that point of time, there are no resources with me also. I don't have much of resources. I don't have a persons or I don't have a people. So who can guide? And I have only one guide of mine in my BTech who used to say all the things. And right now we are having a lot of interactions with the students. And those times in 2013, 8 years, means 7 years back, so there was no much interaction with the faculties also. But right now, so with the evolving of the social media like Facebook, WhatsApp, and whatever these Telegram channels, you are getting a lot of interaction with the corresponding faculty, not only with me, but any other faculties, which means you have more adaptability to the situations, and whenever you get a doubt, you have an sources to can get clear with the corresponding faculty. So don't worry about that. This is not the worst that you are facing. The worst is yet to come. The worst is if you start your preparation in December. If you have not started your preparation, start now. At least start now. You don't need to be worried about how much time is going to be left over. So don't look over the destination. Enjoy the process of journey. If you look over the destination, you will miss the small parts in the journey. So you don't go for the destination, whatever it may be. You just give your workout. You work hard and you work smart. Leave the results to the other side. Up to the examination means once you enter the examinations, after 3 hours of the completion of the examination, nothing will be in your hand. You are going to be entering into your war zone in that 3 hours. And whatever the time of 5 to 6 months is there, right? This is for preparing yourself to embrace the examination of 3 hours. For 3 hours, you are going to spend more than 100%, not more than 100%, you can say any percentage also. You are going to spend more than 5 to 6 months. And every day you are going to spend 5 to 6 hours. So think about that. Don't worry about the result, end result. If you're just thinking about the end result, that's just like you're thinking about a structure without a foundation. You know that, right? We are in civil engineers, obviously. If we want to construct a structure, the foundation is the first thing that we have to construct. Here now, the foundation is your preparation. And prepare well, obviously the structure is going to be good and the result is going to be outstanding. So forget about whether the time is required, sir, because you, me, everybody, if you are going to be get the gate rank, everybody can get. If you are not able to get, then nobody can get. But the point is how much you are pushing yourself towards your maximum performance. That's what all that matters. So work on that. Everybody have 24 hours only. Make sure schedule yourself, because no matter how smart you are, no matter how intellectual you are, if you are not going to be plan the schedule according to the time, then I'm telling you, you are going to do a huge mistake over there. I have done that. I did not make a proper schedule and I did not follow a proper path, and I have wasted around 1 to 2 months for that itself. But again, I restarted from the scratch, and here I am in front of you. I have done my MTech in IIT Hyderabad, as most of the people know, and for the new batches, means those who have not attended the Geotech, so I'm saying it again. So I have completed my MTech in IIT Hyderabad, and I have done the specialization as a geotechnical engineering. So if I can get to that extent, definitely you can also. So keep that in your mind, work hard and enjoy the journey. Forget about the destination. Yeah. So now let's solve some questions. So yesterday I have given this question. So first question, that's going to be wide rectangular channel. Next, come to the question number 2, please. I hope you people are able to see this question. So now let's see the question. A rectangular open channel. So the people, if you have solved these questions, fine. You just look over how the approach is going to be there and whether your approach is going to be correct or not. A rectangular open channel carries a discharge of 15 meter cube per second when the depth of flow is 1.5 meters. So given channel is going to be a rectangle. Okay. And what is the discharge I mentioned over here? 15 meter cube per second. And what is the depth of flow? The depth of flow is 1.5 meter. And the bed slope I mentioned as a 1 in 1690. 1 in 1690. What will be the discharge through the channel at the same depth? What will be the discharge through the channel at the same depth if the slope would have been 1 in 1000? See, here this is the rectangular channel and whose width is going to be B and depth is going to be 1. Okay. Now what is the discharge, please? Area into 1 by n into r to the power of 2/3 into s to the power of 1 by 2. Okay. Now you see, when I keep the depth constant, have I mentioned anything regarding to width? No. Width is constant. And I mentioned depth is also constant. If B and Y both are same, area same, and hydraulic rate is also going to be same. And I did not mention anything regarding to the beds, means roughness. So N is also going to be constant. But I said you, what will be the discharge through the channel at the same depth if the slope is going to be 1 in 1000? Now, can I write this one as a Q directly proportional to s to the power of 1 by 2? So what is S1 I have given? 1 in 1690. What is S2? 1 in 1000. So what I am asking you is what is Q2? For this discharge, for this slope, this is the discharge. Now, Q2 by Q1 is equals to S2 by S1 whole to the power of 1 by 2. What is S2? 1 by 1000. What is S1? 1 by 1690. So then it is going to be 1 by means whole to the power of by 1000 whole to the power of 1 by 2. So 169 by 100 root 13 by 10. 13 by 10. Yes or no? Root of 169 13. Root 110. So 13 by 10 1.3. Then Q2 is equals to 1.3 times of Q1. What is Q1? What is Q1 over here? 15. So 1.3 times of 15. 15 plus 4.5, which is going to be 19.5 meter cube per second. So the correct answer is going to be option B. So I hope you understood this. I did not mention any other changes. If I would have changed the depth, then the answers are going to be changes. So I am keeping the depth as constant. As long as the depth is going to be constant, the flow area is going to be constant over here because width is constant and depth is also going to be constant from the given question. Yeah. So now let's see the next question. Question number 6 or question number 3, whatever it is. So just now we have been discussed about the hydraulically efficient sections, right? Yes. So what is the shape? See, the meaning of optimum channel is efficient channel. The meaning of optimum channel is efficient channel. So as the following, I have given you some shapes: a rectangle, triangle, and a trapezium. So P, Q, R. And I am asking you the ratio of wetted perimeter to the depth of flow. So now, efficient conditions. Just now we have been discussed so that you can understand much more better. So in the case of the efficient conditions, so rectangle first. Yes. What is the efficient condition of rectangle? You tell me. Top width B is equals to 2 times of sides 2y. But what I am asking is wetted perimeter to the depth of flow or not. What is wetted perimeter? B plus 2y. So B plus 2y means B is nothing but 2y, right? Then 2y plus 2y, which is going to be 4y. From here, what is the wetted perimeter to depth of flow? 4. So in the case of rectangle, answer is going to be 4. For rectangle, answer is going to be 4 means it is going to be option 3. You just go through this. In the case of, see, these type of questions can be expected in ESC models. These type of questions can be expected in the case of the ESC prelims questions. So in ESC prelims questions are now shape of optimum channel for rectangle, the P by Y is equals to 4. That is going to be option 3 and the correct option is going to be D. You don't need to go for other options. You can directly simply keep the answer as D. But for now here, I'm going to go for the other things also. Similarly, next come to the triangle. In the case of the triangle, when do you say the efficient condition? When the triangle is going to be symmetrical triangle with apex angle 90 degrees. So what is the weighted perimeter? 2y into root of 1 plus n square. So which is going to be 2 root 2y. Then p by y is equals to 2 root 2. What is meant by 2 root 2? 2 into 1 point. So 2 root 2 is going to be 2.83. Yes, it is going to be 2.83. Then for triangle it is going to be 1. For triangle it is going to be 1. No. So 3 1. And for trapezium. Yeah. Now let's come to the trapezoidal section. In the case of the trapezoidal section, you know that for the half of regular hexagon, you know that m is equals to 1 by root 3. I have already given all these things, yes or no? So m is equals to 1 by root 3. And what is the weighted perimeter? Weighted perimeter is nothing but you see width plus 2 times of I, and I have already given this one as 3b. You please go to that. So because I mentioned all those values earlier itself, so I have given you this value as a 2 root 3y. If you have any doubt, right, please go to the page number 29F. Yes, I already mentioned you here. Please, you see, I already mentioned you the weighted perimeter is nothing but 2 root 3y. Yes. So yeah. So now p by y is equals to 2 root 3. So 2 root 3 is nothing but 3.46. Then it is going to be 2. Yeah, I gave you these values instead of going again and solving those things. It's better. I have already given. You can find out those values. If you still have any doubt, you know that how to find out that. Do you? Yes. So that's about this question. Shape of the optimum channel. You can expect this type of models mostly in the case of ESC rather than the gauge. Okay. Next. So first question, second question, and the sixth question. Next. Third question. You see, a trapezoidal channel of bed width 4 meters. So now I am giving you the channel as a trapezoidal. Yes. And what is the width? Bed width is going to be 4 meters. And side slopes are 1 vertical to m horizontal. So here 1 vertical to 1 horizontal they mentioned. So what is the side slope here? Side slope is m is equals to 1. Laid with the bed slope of 0.002. What is the average boundary shear stress if the depth of flow is equals to 2 meters? You know, my dear, the average boundary shear stress is nothing but gamma W into R into S naught. So that is the reason why when I delivered yesterday, I hope most of you people have gone through the classroom practice questions and solved all these things. If you have not solved, then that's your problem. But you please go through that. When I give you something to solve, you please try to solve. So tau naught is nothing but gamma W into R into S naught. Now, what you need to find out is this R. That's it. What is R? A by B. And in the case of the trapezoidal, my dear, in the case of the trapezoidal, what is area? By plus my square by b plus 2y into root of 1 plus n square. Don't ask me how this came, sir. You know that this is b 1 vertical to m horizontal, and this is going to be the y. Now you please substitute those values of r. So what is the b value here? The b value is going to be 4 meters. And what is the y value? 2 meters. What is m value? 1 into 2 square by b value 4 plus 2 into 2 into root of 1 plus 1 square. So can you please tell me this value? So here 2 into 2, so root of 1, 2 root 2 into 2 plus 4 and 8 plus. So it is going to be 1.243. 1.243 meters. Yes. Now you tell me tau naught is equals to. See what is gamma W, my dear? Gamma W is equals to 9.81 kilonewton per meter cube. What is gamma W value? 9.81 kilonewton per meter cube. See, if they don't mention anything, and especially in the case of the fill in the blanks. So if the question is based upon the fill in the blanks, you must have to take gamma W as 9.81 only. You must have to take gamma W as 9.81 only. So now gamma W 9.81 into, they are asking in terms of newtons, right? Into 10 to the power of 3, because these kilonewtons into 1.243 into what is this now? 0.002. So the tau naught is nothing but 9.81 into 1.243 into 0.002 into 1000. So the value is 24.387 Newton per meter square. I told you, in the case of the open channel flow, the gravity force is predominant than the viscous force, right? Because due to viscosity, there is a shear stress. And what is the magnitude of this shear stress? 24.38 Newton per meter square. However, generally we measure the stresses or pressures in terms of kilonewtons. But see, here it is a Newton per meter square, which means very less shear stress. The shear stress that is accompanying is very small. That is the reason why we don't take care of viscosity in the open channel flow. In most of the situations, we neglect the friction. I want to say one point over here. Why I am solving this question is, you can observe the magnitude 24.38. That's not number. You just look over the next to that. Whatever the units you look over. See, the density of the water is 9.81 kilonewton per meter cube. And if you go for 1 meter, then what is the pressure you are going to get is nothing but 9.81 kilonewton per meter square, right? But this is just in Newton per meter square. So the boundary shear stress developed along the boundary in open channels are very less. Now, because of whom, sir? Because of this bed slope. So as bed slope is going to be this much less, so obviously boundary shear stress is going to be less. Now coming to the next question. This is a very good question actually, because this requires your concepts. Now I'm going to tell you what are the things that you are going to look. See, already I mentioned you when I say the channel geometry is very important. You have to remember for rectangle, for wide rectangle and efficient rectangle. For triangle, special conditions are symmetrical triangle with apex angle 90 degrees, which is nothing but a hydraulically efficient triangle. And for trapezoidal, half of regular hexagon, which is nothing but again hydraulically efficient trapezoidal. Now, in a wide rectangular channel, when I say wide rectangle, you know that the first thing that needs to be comes in your mind is, if it is a wide rectangle, what is the hydraulic radius? Pi. The hydraulic depth is always y. The hydraulic depth for a rectangle, hydraulic depth is always y. Now for a wide rectangle, r is equals to y. The mean velocity is given by Chezy's formula. So what is the average velocity or mean velocity according to Chezy's? C into root rs. In the channel, as a normal depth increases, the Froude number of the flow. what happens to Froude number of the flow as the normal depth is going to be increases. So normal depth means, when I say meaning of normal depth, what is the meaning of normal depth, please? Whenever I mention this as a normal depth, uniform flow depth, right? That is going to be uniform flow depth. So now coming to the Froude number, what is, my dear? What is the Froude number? Froude number Fr is equals to V by root GB. And in the case of the rectangle, D is equals to Y and R is equals to Y. So Froude number Fr is equals to C into root Rs by root of G into D. Froude number Fr is equals to C into root Ys by root of G into Y. And they are mentioning the normal depth or not. Y becomes Yn. And root y will get cancelled. C root s by root g. C root s by root g. Now, can you please tell me, is there any depth function over here? Is there any depth function over here? No. Here, Fr is independent on depth of flow. Fr is independent on the depth of flow. So which means, as the normal depth increases, the Froude number of flow, as it is independent, the Froude number remain same. So Fr, Froude number remain same. You cannot simply say like that. Okay. So if the depth increases now, then the Froude number should decreases, right? No, it's not the actual case. It doesn't mean that when depth increases, the Froude number is going to be decreases or increases or remains constant. It's about whatever the changes I have given in the given equation, as it is changes, then from the given equation Fr is independent of the flow, independent on depth of flow. Is this valid for every section? No. Now you see, instead of this one, now I will give you the modification. Have a look about the modification. So in the previous problem, if I mention you the Manning's equation, in the previous problem, see, in this, sorry, this is a question, right? So in this question, I have given you the changes formula, but instead of changes, if Manning's equation is mentioned, if Manning's equation is going to be mentioned, then what is Manning's equation, my dear? V is equals to 1 by n into r to the power of 2/3 into s to the power of 1 by 2. And what is the channel? Rectangle, wide rectangle. See, keep that in your mind. I mentioned you this is wide rectangle. If I change the channel section, then the values are also going to be changes. Okay. So now, what is the Froude number here? 1 by n into r means yn whole to the power of 2 by 3, because they mentioned the normal depth, right? And s to the power of 1 by 2 by root of g into yn. Now you tell me, what is the Froude number? Directly proportional. Forget about n and s. Y to the power of 2 by 3 by y to the power of 1 by 2. You please take this 1 by 2 to the top, then 2 by 3 minus 1 by 2. 2 by 3 minus 1 by 2, then Froude number is directly proportional to y to the power of 1 by 6. Yn. Yes or no? So here Froude number is going to be directly proportional to yn as normal depth increases. As normal depth increases, Froude number also increases. So here this Froude number, when in the case of Manning's equation, so you cannot just simply take this as a conclusion. If it is a changes, it is independent. But if it is a Manning's, then the Froude number is going to be changes. Okay, so you have to keep that in your mind. Don't just remember it blindly. That's the reason why I have given the modification here itself. Okay, now let's see the last question, one more question now, so that we can go for the break. Yeah. So now in a wide rectangular channel, yeah, in a wide rectangle, again wide rectangle, just now I mentioned, if the channel is going to be the wide rectangle, the thing that needs to come in your mind is R is equals to Y. Now, if the normal depth, see when I mentioned the normal depth, that is going to be uniform flow, because I am discussing about uniform flow conditions, right? So when I mention the normal depth, that is going to be the uniform flow, is increases by 25%. Then what is the approximate increase in the discharge? See, have I mentioned any other details over here? No, I'm just mentioning the depth. So I am discussing about the discharge. What is discharge? Area into velocity. And you know that the velocity is going to be taken by means of the Mannings. Okay. So now what is area of the rectangle? B into Y. In the case of the normal depth, Yn to 1 by n into what is our value? Yn whole to the power of 2/3 into h to the power of 1 by 2. I am comparing, right? Whenever you compare, you know you have to make sure the relation. So B is constant, N constant, S not constant, then Q directly proportional to Yn whole to the power of, see, 1 plus 2 by 3. This is 1, right? 1 plus 2 by 3, which is going to be 5 by 3. So now Q2 by Q1 is equals to Y2 by Y1 whole to the power of 5 by 3. And if I take Y1 as Y, then Y2 increases by 25% or not? 1.25 times of Y. If the normal depth is increases by 25%, so 1.25 Y by Y whole to the power of 5 by 3. Then Q2 is equals to, what is this value? 1.25 whole to the power of 2 by 5 by 3. Which is going to be 1.45 times of Q1. Which means, what is the meaning of 1.45 times of Q1? So more than 0.45 times of the Q1, which means discharge increases by 45%. I can directly say that instead of our final minus initial by final into 100%, we are an engineers and we can say directly the discharge is going to be increases by 45%. So the correct answer is answer B. So that's all, my dear. These are some of the questions regarding to the normal depth. So apart from this, I have mentioned you some questions as an example problems. While we were discussing the conditions itself, I gave you some questions which covers all the models, how to determine the bed slope, how to compare the situations, and what are the relations between the Manning's changes and the Darcy friction factor. C is equals to root of 8g by f, and C is equals to 1 by n into r to the power of 1 by 6. And I'll conclude this with this last question, because it is based upon the Froude number. Yeah. So now you see what is the channel I am giving here? Symmetrical trapezoidal channel. So that's the reason why I asked you to look over the special conditions. We have seen wide rectangle, we have seen symmetrical triangle with apex angle 90 degrees. Now symmetrical trapezoidal channel is a half of a regular hexagon. So it is going to be the half of regular hexagon. When you know half of regular hexagon, it carries a discharge. What is the discharge it is carrying? 1.25 meter per, sorry. It is carrying a discharge of 5 meter cube per second with a velocity of 1.25 meter per second. The approximate value of the Froude number if G is equals to 10 meter per second square. Okay. Now, what is Froude number? What is Froude number? Again, so you know that Froude number is nothing but Fr is equals to V by root GV. Don't remember as V by root GY. that is V by root GD. Now, for a regular hexagon, now have you remembered the cross-sectional properties for regular hexagon? Area is nothing but root 3y square. Hydraulic depth is going to be 3 by 4y. Okay. Sir, they did not mention any depth, sir. Then how come I find out the d value? You keep in your mind, I have already given the v value. I know v, but I need to find out d. For finding the d, I require y. What is d? For regular hexagon, the trapezoidal section has a regular hexagon. What is d value? 3 by 4y. So I need to find out y. Then how come I find out y, sir? Sir, from these given details, if I can find out from q and v, can I find out area or not? Yes. Q area, q is equals to a into v. Area is equals to q by v is equals to root 3 y square. So root 3 y square is nothing but 5 by 1.25. 5 by 1.25 makes 4. Then what is y value, please here? Find out the y value. What is y value? So 4 by root 3 square root. So I hope y value is going to be 1.52 meters, 1.519. So that's going to be 1.52 meters. Now you substitute the d value over here. So the d is nothing but 3 by 4 into 1.52. So it comes as a point. Sorry. This is 1.14. 1.14. So from the details, you know, this is the details. Don't ask me, sir, how this details came, because you please go through the channel geometry. There I have explained the cross-section details clearly. So area, by substituting area, I have find out the y value, and from there I can find out the Froude number. Fr is equals to, what is velocity I have mentioned? 1.25 by square root of g value 10 into 1.14. So find out these values. So it is going to be 0.37. So they are asking about the rounded to two decimals, right? The answer is going to be 0.37. So that's all with the questions and uniform flow topics, and so far whatever the discussion we have made. Please go through this, and now you can understand. So I have given you more questions than the discussion. The actual concepts are going to be started now. The actual means the beauty of the open channel flow is going to be started now. So far, it's like knowing the basic things and knowing whatever the new terminologies. But now, next we are going to see the actual scenario happening in the situations and how we are going to find out those. So by means of the specific energy, a beautiful concept is there that we'll discuss after the break. So let's have a break to break our breakfast. So now it's already 9:17. I'm giving you the break of 30 minutes. So let's take 9:20. So you will start our next session by 9:50, and from 9:50 to 1 o'clock. So that's a direct one more session. Have a breakfast. So of 30 minutes. Yeah, I'm giving 30 minutes, not 20 minutes. So that I don't give any break later. I'm not going to give any break. So I have a breakfast, and we'll meet at 9:50. Come at 9. So again, let's start our session. Okay. So now let's come to the next important topic we need to look over is specific energy. So before going to the next type of flows, a gradually varied flow and rapidly varied flow, we need to discuss about this energy concept known as a specific energy. So what is this specific energy? Why the strength is very less? Today is Sunday. Because of that Sunday, is it Sunday effect or not? Okay. Sunday morning rain. Seriously, yes. If early morning rain occurs now, even during the break time also, I'm not feeling to take the class, but I have to take the class. So okay, and the heartbreaking news was out yesterday evening. So MS Dhoni got retired. I hope everybody knows that. Even Suresh Raina also got retired. So the way that he existed in the cricket and the way he exited in the cricket. So his entrance and exit both are like runouts. Okay, next. So I hope most of the people have joined our session. Now let's see next topic. Specific energy. So yeah. So in the case of the specific energy, first of all, what is meant by this specific energy? Before going to this specific energy, so let's go with the basic again. Let me draw the longitudinal section. So there is a longitudinal section and having some bit slope, and whatever this is nothing but some water surface. I'm not showing you exactly parallel. So it can be either parallel or it can be following also, means whether it is a varied flow or uniform flow. Keep that in your mind, a specific energy. So this concept can be useful for both the varied flow, means non-uniform flow and uniform flow. So let me take this as a hydraulic gradient line. And you know, whatever this is nothing but this is going to be total energy line. Sir, why the total energy line is falling? You tell me. The total energy line is falling because of the head losses due to friction. So whatever the difference between these is nothing but head loss due to friction. This is due to head loss due to friction. Okay. So I'm showing you for the perspective, but in reality, as you know, the shear stress is going to be very, very less. In one of the questions we mentioned, I told you in open channel flow, the boundary shear stress is very less, friction is very less, and the resistance offered is also very less. The head loss are also going to be very, very less. So at any particular section, let me take this is an arbitrary datum. This is an arbitrary datum. Now, at any particular section, so whatever this is nothing but velocity head v square by 2g, and this is going to be the depth of flow, and this is going to be the datum. So now at any section, what is the total head, please? Total head h is equals to, at any section, total head h r t is equals to, so v square by 2g plus y plus z. So this is going to be the total head. Okay. Now, sir, you have said this one in the earlier, but now why you are discussing again? Is the total energy same as the specific energy? Now there comes the point. What is meant by specific energy? You see, you know that whatever the bed slope is, even whatever the questions we have solved also, the bed slope is going to be 1 in 2000. What is the meaning of 1 in 2000, 1 in 3000 like that? For 2 meters of horizontal, you are going to raise a 1 mm. See, in reality, if you observe the bed slope, it seems very less. Almost the channel bed looks like horizontal, but it is not horizontal. The channel bed looks like horizontal, but it is not horizontal because water requires a very light steepness to cause the flow. Now, as we are analyzing, whenever we analyze, we idealize the conditions, right? So whenever we analyze, we idealize the conditions. Now we are going to idealize the conditions as channel bed slope is very less. As the channel bed slope is going to be very less. So now I am going to assume the channel bed. This is a channel bed. As the channel bed slope is very less, for analysis, assume channel bed as horizontal and frictionless. Assume channel bed as horizontal and frictionless. So as a channel bed slope is going to be very less, assume the channel bed as horizontal, and now as you know the boundary shear stress is also going to be less. We are going to assume the channel bed as a frictionless. So then what happens? If I assume the channel bed as horizontal, you observe if I assume the channel bed as a horizontal, then the datum and the channel bed both are same or not? Then the datum and channel bed both are same, because if I assume the channel bed as a horizontal, then the datum head is going to be same. Yes or no? Now there comes the specific energy. So now what is a specific energy, sir? Specific energy means total energy per unit weight. Per unit weight. So what is the meaning of total energy per unit weight? See, what is mean by V square by 2G? Kinetic energy by unit weight. What is meant by kinetic energy? Please tell me. Kinetic energy is nothing but half mv square by unit weight. If I write weight, weight is nothing but mg. Mm gets cancelled. Then this is going to be v square by 2g. Similarly, potential energy, you know that potential energy is nothing but mgh. Here h is nothing but y plus z. So potential energy by weight. So mg will get cancelled, then it is going to be y plus z. So this is nothing but, see, whatever the energies we have is a total energy is nothing but kinetic energy plus potential energy. Because in the case of the open channel flow, we don't take a pressure. So total energy per unit weight, which is nothing but kinetic energy per unit weight and potential energy per unit weight. So now, what here we are mentioning is now, let's see. So total energy per unit weight by taking channel bottom as a datum. By taking channel bottom as a datum. So what is the meaning of channel bottom as datum or channel bed as datum? So channel bed or bottom as a datum. Keep that in your mind, my dear. Whenever I say the channel bed and the channel datum both are same, then what is z value? 0. Now, in this equation, if I keep z is equals to 0, then I can write this one as a specific energy represented with the E. So now, finally, what is a specific energy? specific energy is nothing but Y plus V square by 2G. What is specific energy? Y plus V square by 2G. So now here this specific energy is going to be looks like Y plus V square by 2G. And you know that Y is nothing but the depth of flow, V square by 2G is nothing but the velocity. Or I can say Y is nothing but potential energy, because if I take the channel bed as a datum, then what is the potential energy? mgy, potential energy per unit weight, and this is going to be kinetic energy per unit weight. We are going to call it as a potential head and kinetic head. So what is the specific energy? Specific energy is nothing but total energy per unit weight by taking channel bottom as a datum. Oh, sir, why you are taking channel bottom as a datum, sir? Because as channel bed slope is very less, I am going to assume the channel bed as horizontal and frictionless. So, and now, see, have you remembered the corrections earlier, please? I hope you remember the corrections, please. So, in the case of the corrections, if you remember well, I have applied two corrections. One is the kinetic energy correction factor. So, the actual equation of the kinetic energy is Y plus alpha into V square by 2G, where you know that alpha is nothing but kinetic energy correction factor. Kinetic energy correction factor. And for turbulent flow, alpha is equals to 1.0 to 1.15. This is for turbulent flow. Sir, in examination, what I have to do with the alpha, sir? In examination, if nothing is mentioned, don't take alpha as an average or minimum or maximum. You do take alpha is equals to 1. So, alpha is equals to 1 if not mentioned. You have to take it as alpha is equals to 1 if not mentioned anything. If not mentioned anything regarding to the flow. So this is known as a specific energy. What is specific energy? Total energy per unit weight by taking channel bottom or bed as a data. So now let's come to the equation once again. E is equals to Y plus V square by 2G. E is equals to Y plus V square by 2G. Now I can rewrite this one as what is Y? Y is nothing but potential head. And V square by 2G is nothing but kinetic head. Y is nothing but potential head and V square by 2G is nothing but kinetic head. So now you can see the purpose of the specific energy is equals to E is equals to Y plus, can I write V as a Q square by 2G A square? Yes. V is nothing but Q by A. So Q square by 2G A square. Yes or no? And A is a function of whom? Y. Now you see the relation over here as in a channel for given discharge. For a given discharge, the specific energy is a function of depth of flow. The specific energy is a function of depth of flow. So now, what is meant by specific energy? Specific energy means total energy per unit weight by taking channel bottom as a data. And whenever the channel bed is going to be horizontal, means this is the analysis. This is the assumption we are going to take. So you please remember that. And this assumption is very, very important. Throughout the specific energy, I am going to use this assumption as channel bed slope is very less. For analysis, assume channel bed is horizontal and frictionless. So now, what is the purpose of this specific energy? See, this specific energy is going to be gives a relation between the So now, whenever I want to use a specific energy, what is the purpose of specific energy? So the applications of the specific energy is specific energy is to define the critical flow, critical flow, and to analyze the flow over transitions. To analyze the flow over transitions. Sir, why alpha is taken, sir? If you, so you please go back to the kinetic energy correction factor. Alpha is 1.10, that is for straight prismatic channels, I told you. So, but the range is going to be 1.02 to 1.15. Yeah. Now, so what is the meaning of this flow over transitions? Look, question number 1 for you. Do you think the channel bed has same slope throughout the length of the channel? Do you think the topography of the soil mass is going to be same everywhere? Do you think the topography of the soil is going to be same everywhere? Do you think the ground level is going to be horizontal? No. So in reality, the ground level is going to be undulated. Yes or no? Whenever the ground level is going to be undulated, you have to construct the channel regarding to the ground level. Yes or no? So whenever you are going to decide that, means you based upon the low-lying area and based upon the high-lying area, you need to change the slope of the channel bed. You need to change the slope of the channel bed. Sometimes you have to lower down the channel bed. Sometimes you have to raise the channel bed. Yes or no? So that is nothing but the transition. And that is nothing but the transition. In order to analyze those transitions, we are going to use the specific energy. So in order to go to that, first let's see what is the relation between the channel bed and specific energy. You see, what is the specific energy? By taking the channel bottom as datum. See, I am talking with respect to the channel bed. I am talking with respect to the channel bed. Now let's see what is the relation between specific energy and channel bed. Relation between the specific energy and the channel bed. So what is the relation between the specific energy and channel bed? Now, you see, in the case of the channel bed, do you think that channel bed, see what is the assumption I have made over here? The assumption is going to be channel bed is going to be horizontal. So do you think that channel bed is going to be horizontal throughout the length of the canal? No. See, based upon the obstructions, sometimes you need to raise the channel bed. And whenever there is a low-lying area, you have to lower down the channel bed. Yes or no? So, first one. A. If channel bed rises, or we can call it as a hump. So now, listen to me carefully. What I am drawing here is, please, what is this? This is a channel bed. I am assuming it is a horizontal. Yes or no? And when somewhere there is a high-lying area, due to this high-lying area, means due to the rise in the ground level, then I have to raise the channel bed. And you cannot raise the channel bed suddenly. You have to raise it as a smooth transition. What is this? This is nothing but a smooth transition. So the channel bed is going to be rises like this. Now, the channel bed has been rises like this. This is the channel bed. Okay. And as you know, this channel bed is going to be rises by, let's say, delta Z. So by delta Z. when channel bed is going to be rises by delta Z. Now, you see what is the assumptions I have made over here? You please observe. What is the assumption? Soil is going to, sorry, channel bed is going to be horizontal and frictionless. What is the meaning of frictionless? The meaning of frictionless is we are going to neglect the head losses. Yes or no? See, generally the head losses are going to be very less. If I assume the friction is going to be neglected, see, generally always the total energy line is going to be falling. Always the total energy line is going to be falling because of the head loss. Yes or no? And if I neglect the head loss, then HF is equals to 0, then the total energy line is going to be horizontal. What is the meaning of total energy line horizontal? No change in the total energy. So now what I am going to do is I'll draw the total energy line. Like this. Yeah. So whatever this line is going to be, total energy line, keep that in your mind, dear students. Why I have taken the total energy line as a horizontal? Because we assumed that the channel bottom is going to be frictionless. Whenever I assume the channel bottom is going to be frictionless, what happens to total energy line? Total energy remains same without any loss. But what is mean by? Let's say, yeah. But what is mean by specific energy? Specific energy is nothing but total energy by taking whom as datum? Channel bed as datum or arbitrary datum? By taking channel bed as datum. So now you see, before the rise, this is the total energy line and this is the datum. This is the channel bed, yes or no? And whatever the specific energy is nothing but, this is nothing but the specific energy. Let's take it as even. See, this is a total energy line. So you know that specific energy is nothing but a total energy only. Keep that in your mind. Specific energy is nothing but a total energy. But the datum is not going to be the arbitrary datum. The datum is going to be channel bottom. So at this point, this is the total energy line. This is the channel bed. So this channel bed is nothing but datum. From the total energy line to the datum, that is nothing but specific energy even. Okay, fine. Now, let's come to this section. At this section, now, at this section, already channel bed has been raised by delta Z. Now, this is going to be the channel bed or not? Now, what is specific energy? Specific energy is nothing but total energy by taking channel bed as datum. So now this is the channel bed. So now if you see this channel bed as datum, then this is going to be E2. So what is happening to total energy? The total energy is going to be remain same, which represents the TEL. But what happens to specific energy? As the channel bed is going to be changes, from here to here, as the channel bed is going to be changes. See, this is total energy line, this is a datum, channel bed. So whatever the difference or elevation between these two is nothing but the total energy as a specific energy. And when the channel bottom is going to be rises, the elevation is going to be decreases or not. So if I say some flow is going to be happen over here, and initially if this is the level of water, this is the depth of flow. What is this? Y1. And what about the above? This is nothing but V1 square by 2G, right? That is nothing but specific energy. What is specific energy definition? So Y plus V square by 2G. Now, so from this can I write? When the channel bed is going to be rises, what is happening to specific energy? Specific energy is going to be decreases. Sir, why you are taking up to E2 only, sir? Because this is channel bed, sir. If I ask you what is the total energy here, na, then there is going to be E2 plus delta J. Because this is the arbitrary datum. But if I say specific energy, you cannot take arbitrary datum. You have to take the channel bed as a datum. So from here, I can write E1 is equals to E2 plus delta Z, where E1 is going to be greater than E2. E1 is going to be greater than E2. Can I write? As a channel bed rises, the specific energy is going to be decreases. As a channel bed rises, specific energy is going to be decreases. Or in other words, deeper the channel, higher the specific energy. Higher the specific energy. Deeper the channel, higher the specific energy. So whatever the depth of flow, initial depth of flow, this is going to be the initial depth of flow. The initial depth of flow is going to be Y1. And this is a total energy line. You know that above the hydraulic gradient line, the total energy line is going to be having a magnitude of V1 squared by 2G. So now the question is, now everybody, I'm asking this question. So let's see that. Let's see that. You see, if this is a channel bed I'm going to take, and I'm raising the channel bed like this. Now, my question is, if the water is coming over here, I have released the level of water. I have released the level of water. So initially, let's take the depth of the flow as Y1. So I'm showing you the longitudinal section, my dear. This is a longitudinal section. So you are allowing the flow of water, okay? Now, my question for you is, initially the level of water up to this point also, the level of water is going to be same. Now, this is a transition zone. Whatever this is known as a transition zone. What is the transition is happening over here? The transition that I'm seeing over here is the channel bed is rising. Now, when the channel bed is going to be rising, think and say clearly, when the channel bed is going to be rising, what is happening to specific energy? What is happening to specific energy? So just now I told you the specific energy is going to be changes. Yes or no? When channel bed rises, the specific energy is going to be decreases. Now, the biggest question for you is, do you think the water load is going to be remain same like this? Or it is going to be changes? Do you think the water load is going to be remain same or it is going to be changes? Definitely it is going to be change. Why? Because if you take the water load is going to be remain same, yes or no? See, whenever there is a change in the specific energy, I told you the specific energy is a function of whom? The specific energy is a function of whom? Depth of flow. Now, whenever there is a transition, here, the channel bed is going to be rises, then definitely the specific energy changes. And as a specific energy is a function of depth, if a specific energy changes, then the depth of flow is also going to be changed. Yes or no? Tell me now. Do you think the water level is going to be horizontal? No. The water surface may rise or may fall. The water surface may rise or may fall. Sir, how come it is going to be rise or fall, sir? It depends upon the initial type of flow, whether it is going to be subcritical or supercritical. It depends upon the initial approach flow, subcritical or supercritical. So you know that how to classify whether the flow is going to be subcritical or supercritical. How to classify whether the flow is subcritical or supercritical? When the Froude number is going to be less than 1, we call it as subcritical flow. When Froude number is going to be more than 1, we call it as a supercritical flow. And once the channel bed is going to be horizontal, now the water surface is going to be again horizontal. So you please observe in this zone, whatever the zone, the water levels are going to be fluctuates or not. Do you think water level is going to be remain horizontal? No. As a channel bed changes, specific energy changes. When specific energy changes, then the depth of flow is also going to be changed. That is nothing but the analysis of to analyze the flow over the transitions. To analyze the flow over the transitions. I hope you understood the meaning behind it. So whenever there is a transition, the water level either may rise or it may fall. And what is the depth? So once it comes, what is the depth of flow over here? What is the depth of flow? This is going to be the Y2. Or what is the depth of flow? What is the Y2 value? So I want to find out the depth of flow. And I told you from the starting of the open channel flow onwards, our main point is to look over the depth of flow. Our main point is to look over the depth of flow only. Yes or no? So whenever I do changes, why this change is happening, sir? Because due to the changes in the topography of the soil mass or topography of the ground surface. You know that the ground surface is not going to be planar and it is going to be undulated, right? So based upon the conditions and wherever there is a possibility, we are going to provide one transition. So is this a longitudinal section or a plan view? Longitudinal section. And similarly, now, if you observe, this is case A. Similarly, now, the channel bed may falls also. The channel bed drops or falls. If the channel bed is going to be drops or falls, when water rises, sir, wait for that, sir. I am going to discuss that one only. We don't know whether it is going to be rise or fall. See, we don't know whether it rises or falls, but we do know is definitely there is a change in the water level. There is a change in the water level. For that, wait for the moment. So I'm going to say that later. Okay. Meanwhile, sir, if water level rises, then it may happen that specific energy may remain same. No. What is specific energy? It's not about water level. Water level plus velocity hit by, my dear. Okay, fine. So now let's come to the when channel bed is going to be drawn. This is a channel bed. Now when this channel bed is going to be dropped, when the channel bed is going to be dropped by delta Z. So now the channel bed is going to be dropped by the delta Z. Now you know that as we assumed the channel bottom as horizontal, then the total energy remains same. This is nothing but the total energy. The total energy remains same. So when that total energy is going to be same, now come on, you tell me, what is the specific energy over here? See, in simple words, the specific energy means from the total energy line to the channel bed, whatever the elevation, total elevation is there, this is nothing but the specific energy E1. And from the total energy line to the channel bed, this is nothing but the specific energy E2. Okay. So you must have to look over specific energy means with respect to channel bed, not with respect to the arbitrary datum. This is arbitrary datum. This is arbitrary datum. But for the specific energy, that datum should be channel bed. Okay. So now, my dear, whatever these two, these are nothing but the arbitrary datums. So here you can say what is happening to specific energy now? E2 is equals to E1 plus delta Z. So in this case, E2 is greater than E1. E2 is going to be greater than E1. So now, in the case of the channel bed drops, the specific energy is going to be increases or decreases? Increases. When specific energy is going to be increases, again the depth of flow, as a specific energy changes, the depth of flow is also going to be changes. Area is a function of y only, right? So in a channel for a given Q, E is a function of y. So whenever there is a change in the specific energy, then there is a change in the depth of flow. Now we have to look over how this depth is going to be changes. We have to look over how this depth is going to be changes. Okay. Now, So this is one transition. This transition is known as a channel bed transition. What is this transition? Channel bed transition. So in the longitudinal section, channel bed rises or drops. So this is one transition, but here it is going to be rises. So I hope you understood. Now, what we need to analyze is how the depth is going to be rises or falls. And at the end, one more condition I'm going to say here. C. Look, this is A and B, and now coming to the C. Channel bed remain horizontal. Channel bed remain horizontal. So when the channel bed is going to be remain horizontal, my dear, as long as the channel bed is going to be horizontal, now you say, is there any change in the datum now? No. What about the total energy? The total energy line is also going to be horizontal. What is the meaning of total energy line horizontal? Frictionless. And now, what about the specific energies, please? The specific energies here, E1 and E2, both are same. So as long as there is no change in the datum, there is no change in the specific energy. There is no change in the specific energy. So I can say if we neglect the friction, see, you please observe all the three conditions. I can say if we neglect the friction, the total energy will remain same. The total energy will remain same, but the specific energy may be same or may get increases or may get decreases based upon the channel bed. Based upon the channel bed. If channel bed is going to be rises, then the elevation between the total energy line and channel bed is going to be decreases. If channel bed is going to be falls, then the elevation is going to be increases, which means specific energy is going to be increases. And if there is no change in the channel bed, no change in the specific energy. So the conclusions I can make over here is conclusions. So the conclusions are whether it is a uniform flow or non-uniform flow, for any flow, whether it is going to be uniform flow or non-uniform flow, for any flow, if frictional losses are neglected, total energy remain same, but specific energy may increase or decrease or remain same based on the channel bed level, based on channel bed transition, I can say. Okay, sir, if I consider the friction losses, sir, if you consider the friction losses, total energy line is going to be always falling, but the specific energy may increases or may decreases based upon the channel bed transition only. Keep that in your mind. I am going to repeat this point again and again and again and again. As long as there is no rise or drop in the channel bed, no change in specific energy. If there is a rise or drop, then specific energy may increases or may decreases, but total energy remains same. So is there any possibility that y2 is equals to TL? No, my dear. Baba, when if you take the depth itself as our TL, then what is the velocity? Velocity is going to be 0. See, what is mean by specific energy? Y plus v square by 2g. Y plus v square by 2g. Okay. So don't think like the total energy line is going to be the depth of flow. Now, for these conditions, this is one transition. This is one transition. What is the transition over here? So this transition is going to be the channel bed rises or drops transition. But first, let us find out this specific energy one more means. So from this equation, I am going to make sure how to study the nature of the flow. So I need to know what is going to be happen. Listen to me carefully. You know that these two are the channel bed transitions. One is rise, another one is going to be drop. Now my question is, what happens to the water level? Does the water level is going to be rises or falls? Does the water level is going to be rises or falls? For that, we are going to study the specific energy. We are going to study the specific energy, as you know that E is nothing but Y plus V square by 2G, where Y is nothing but potential head and V square by 2G is nothing but kinetic head. And this can be written as Y plus Q square by 2G A square. Y plus Q square by 2G A square. Okay. So now what I'm going to do here is I will draw the variation of the specific energy with respect to depth. I will draw the variation of the specific energy with respect to depth. So let's go back over here. Now, if you observe this carefully, in these cases, I can directly write this one. So E is nothing but Y plus Q square by 2G A square. So let's take this potential energy separately and the kinetic energy separately. So now I want to study the variation of the depth with respect to the specific energy. So as a layman, we know that when channel bed rises or drops, so what is going to be happening? Specific energy changes. And if a specific energy changes, what happens to the depth of flow? So for that, I'm going to split into two parts. I'm going to split this into two parts. So part number one, if the specific energy is going to be potential energy line. So if the specific energy is going to be potential energy line. Now, what is the variation between these two? This is going to be the potential energy and here it is going to be the depth of flow. See, the meaning of E is equals to Y means whatever the slope Y by E is equals to 1 R. What is the meaning of slope? Slope means Y axis by X axis. Y by E is equals to Y. Okay, what is the meaning of E is equals to Y? Whatever the specific energy increases, that much depth is also going to be increases. If I plot this line, what is mean by Y is equals to mx? What is mean by Y is equals to mx? That is the line passing through the origin R0. And what is m over here? 1. So now if I draw, this is going to be a graph. As E increases, Y is going to be increases. And what is the angle made over here is nothing but 45 degrees. Because whatever the slope, this slope is nothing but Y by E is equals to 1. When tan 45. So whatever this line, we call it as a potential energy line. What we call potential energy line. So I hope you understood what is happening over here. So first one is going to be E is equals to Y, and C, you know that this is going to be the potential energy and this is nothing but the kinetic energy. Okay. So first I am taking a potential energy line. This is a line. And now second one is E is equals to Q square by 2G A square. E is equals to Q square by 2G A square. Now, you know that Q is constant, yes or no? And G is also a constant. But E is a function of, E is inversely proportional to A, and A is a function of Y. A is a function of Y, yes or no? So now, let's draw the figure. Now this is E and here it is going to be Y. Okay. So now, my dear students, can you please tell me what is going to be happening in this case? In the case of the, see, this is the potential energy. I'm splitting into two parts. I'm splitting this into two parts. So let me say this one as E1 and let me say this one as a E2. Okay. So for better understanding of yours, I'm going to split that into two parts. One is potential energy, other one is going to be kinetic energy. So now I'm going to write this as, whenever there is a change in the energy, now you see, as a depth is going to be increases, as energy is going to be increases, E is inversely proportional to A. Yes or no? When inversely proportional to A, what is the meaning of inversely proportional? See, directly proportional means a graph is going to be rising. Inversely means if X increases, Y should decrease. If E is going to be increases, Y should decrease. And moreover, E is inversely proportional to A square, which means the variation is no more linear. Do you think it is a linear variation? No. And specific energy increases here, the depth is going to be decreases. The depth is going to be decreases. Now, you see, if I draw the curve, how does the curve looks like? Is it going to be a rising graph or falling graph? Think and say. For the potential, see, this is potential energy line, and for the kinetic energy, this second part is going to be the kinetic energy, right? The second part is nothing but kinetic energy head. So in the case of the kinetic energy, as a specific energy increases, depth of flow will decrease. Energy increase, depth of flow will decrease. So now, if I draw, the curve is going to be, looks like this one. And whatever, this is nothing but kinetic energy line. Kinetic energy line. I know this question will be asked. Sir, why it is curve, why not linear? Just now I said, you please go through that. Explain how the total energy is going to be same and specific energy changes. After all the discussion I have made, if you are asking this question, which means you have not listened that. You see, chala bit rises, specific energy constant. Chala bit rises, specific energy is constant. No, it is changing. But what about the total energy line? What is mean by total energy line? This is what is mean by total energy? Total energy means from the total energy line to the arbitrary datum. So here E1 and here it is going to be E2 plus delta Z. Okay. So now, my dear, but I want whom? See, I am studying the total variation by means of the graphs. Okay. Now, what I did is I have done the E is equals to Y separately and E is equals to Q square by 2Ga square separately. Now, what I do is, there comes the curve. Please stop and listen first. Stop and listen. Now, specific energy curve. We call it as specific energy curve. So what is a specific energy curve, sir? Tell me. This is going to be the potential energy and this is going to be the kinetic energy. And what we require is the total specific energy, means whatever the potential energy plus kinetic energy. And what is this kinetic energy? I can write this kinetic energy as Q square by 2Ga square. Now, let's take okay. So this is an axis. On the x-axis, we are going to take the total specific energy. On the y-axis, we take the depth of flow. So I am going to study the variation of the specific energy with respect to depth. Okay. So with this, we are going to finalize. Listen to me carefully. What is a specific energy? Specific energy is a potential energy plus the kinetic energy. Yes or no? Potential energy plus kinetic energy. Think. You see, in the graph 1, at a particular specific energy, now you see whatever this is nothing but the specific energy E is equals to what? Yes or no? At this particular point. So now as the depth increases, the specific energy is also going to be, means the potential energy is also going to be increases. Yes or no? But in the case of the kinetic energy, at larger depth, the velocity is going to be less. At larger depth, the kinetic energy is going to be less. Yes or no? So this is a kinetic energy here, and this kinetic energy, this is known as V square by 2g. So Q square by 2g, A square is nothing but V square by 2g. Now, if at a larger depth, the velocity head or kinetic energy is less, and at a larger depth, the potential energy is going to be more. Yes or no? Now, first you draw the potential energy line. So whatever, this is nothing but the potential energy line. And what is the angle made by the potential energy line? So I can call this one as a PE line. What is nothing but PE line? Potential energy line. Okay. Now, what about the kinetic energy line, sir? The kinetic energy line is going to be looks like, see, this is a potential energy line, right? The kinetic energy line looks like this. Yes or no? This is going to be the kinetic energy line. Whatever, this is nothing but the kinetic energy line. So now this is going to be KE line. But what we want is going to be the potential energy plus kinetic energy. Yes or no? So now you have to combine both. When you combine both, then the specific energy curve has both the potential energy and kinetic energy. Now you see, at a larger depth, this is the magnitude of the potential energy. Can I say that? And at a larger depth, this is the magnitude of the kinetic energy. So if I draw a graph, at larger depths, potential energy should be more and kinetic energy should be less. Potential energy should be more and kinetic energy should be less, because larger the depth, lesser the velocity. Remember that? Larger the depth, lesser the velocity. And at the smaller depths, you can see potential energy is going to be less, right? Here, this is nothing but less. So at a smaller depths, potential energy is going to be less and kinetic energy is going to be more. So now let's reconstruct the entire curve. If I reconstruct the entire curve, you see, if you draw the graph, then I'm going to show you here as the graph looks like. The graph looks like this. And my dear students, this is not going to be parallel. Please observe carefully. This is not a parallel to the potential energy line. You can draw in another way. Okay. Yes. Whatever, this is nothing but a potential energy line. This is potential energy line. Is it 45 degrees? No. Yeah. So then we are going to draw the actual graph. Yes. So whatever this curve, this is known as a kinetic energy or specific energy curve. This is known as a E curve. What is mean by E curve? Specific energy curve. And what is mean by this line? Potential energy line. And you see at larger depths, you can observe, listen clearly at larger depth. So from the y-axis to the potential energy line, this is nothing but the potential energy or not? Yes. And from this potential energy line to the kinetic energies to this E curve, whatever, this is nothing but a v square by 2g. So here this is known as a y, and here this is known as a v square by 2g. V square by 2g. Observe carefully. At larger depth, I am including, means I am subscribing both the curves. I am drawing this curve as a E curve. And how this has been formed, sir? You please observe. At a larger depth, the potential energy is y, and kinetic energy is going to be very less, v square by 2g. Yes or no? So similarly, yes. Similarly, at smaller depth, you see this is going to be the potential energy y, and what about this one? This is going to be the kinetic energy v square by 2g. So what is E value here? Y plus v square by 2g. And what is the E curve? E means y plus q square by 2g a square, or y plus v square by 2g. I hope you understood how this curve has been constructed. So just by joining these two lines, we are going to get this curve, E curve. Now there comes the discussion of the E curve. Point number 1. The specific energy curve gives the variation of specific energy versus depth of flow for a given discharge Q. So this is for a given discharge in a given channel. For a given discharge, this is the variation. Very good question. So one of our students, sir, E is a function of y, then why we plot graph by taking E on the x-axis? Remember, E is a function of y, but are we predicting the E value? See, whenever there is a change in the channel bed, I can directly say y, means I can directly say the specific energy changes, whether it increases or decreases. But can you predict the behavior of the water? No. I can say specific energy decrease, but I cannot say water level rises or falls. So here known is specific energy, unknown is depth of flow. So that is the reason why while I was drawing the known axis means x-axis, I am taking E. And by knowing the specific energy, then I am going to predict the behavior of the flow. So now, yes, have a look about this. This is a specific energy. And if you see, this is the minimum point of the specific energy or not. Whatever, this is nothing but the minimum ordinate of the specific energy. Yes or no? And whatever this minimum ordinate of the specific energy, let's take it as a E minimum. Let's take it as a E minimum. And now, my dear, whatever the depth corresponding to the minimum specific energy, this is known as critical depth. What we call? We call it as a critical depth. So there comes. What is the application of the specific energy, please? So to define the critical flow, I was saying you the critical flow at the starting. So I hope you remember the critical flow. When do you say critical flow? When the Froude number is equals to 1, I say it as a critical flow. If you remember that. Okay. If you remember that, so that critical flow, the actual definition of the critical flow means the flow at which specific energy is a minimum, then you are going to take it as a critical flow. So now you may ask me a question, sir, why you said the critical flow is going to be critical at the minimum specific energy? Now let me show the proof. You know that for anything to be minimum or maximum, you know that E is equals to y plus q square by 2g a square. Yes or no? For E to be E minimum, just in the previous concepts itself, for anything to be maximum or minimum, then for E to be E minimum, then dy is equals to 0. dE by dy is equals to 0. So what is dE by dy, sir? dE by dy is equals to integration of, means the differentiation of y1 plus q square by 2g into, see the a is a direct function of y, yes or no? So now are we going to differentiate with y or with respect to a first? So here first of all we have to do indirect derivative. Then first I have to differentiate with respect to a. 1 by a square means minus 2 by a cube, and then we need to differentiate a with respect to y. dA by dy is equals to 0. So first of all, q square by 2g, 1 by a square. A is a function of y. So first you differentiate the given a, and then with respect to y. So minus 2 by a cube into dA by dy is equals to 0. Now you send this minus value to the other side. 2 gets cancelled. And meanwhile, you see, let me take an irregular channel. If this is the water surface, okay. Now, my dear students, always we are taking the analysis at the free water surface or not? We are taking the analysis at the free water surface, because at a free water surface, the pressure is going to be 0. So for this channel, this is the top to the T, and let me take a small element over here, a small rectangular element of depth dy. Can you tell me the elemental area over here, please? If this is an awesome channel, what is the elemental area over here? The elemental area dA is equals to T into dy. Can I write like this? Whatever the elemental area is nothing but dA is equals to T into dy. Then can I write T is nothing but dA by dy. T is nothing but dA by dy. Now substitute dA by dy as a T. Then you send the minus to the other side. When you send the minus to the other side, q squared by g into whatever this is dA by dy, T by a cube is equals to 1. And can I write this one as q squared by g is equals to a cube by t? I hope you might have remembered this condition. And I told you this is nothing but the critical flow condition, right? What is this? Is nothing but the critical flow condition. So whenever this is a critical flow condition, or still if you have not satisfied with this, then you can simply say from here itself as so R, you can write q square by a square, which is nothing but v square into T by g into a is equals to 1. So a by t is nothing but d, right? A by t is nothing but d. V square by gd is equals to 1. And from here, v square by gd is nothing but fr square r, which is equals to fr square. And from here, I can write fr is equals to 1. So either this form or this form, whenever the Froude number is equals to 1, that's nothing but critical flow, I told you. But why? Why the Froude number is equals to 1? Now I am telling you here. I told you the classification as when Froude number is 1, critical flow. But why? Whenever the specific energy becomes a minimum, then q squared by g is equals to a cube by t, which leads to Froude number is equals to 1. And then the flow is going to be the critical flow. So I hope you understood. The point number 1 is specific energy curve represents the variation of E versus Y for a given discharge. Point number 2. So critical flow occurs at a minimum specific energy. The depth corresponding to the critical flow, the depth corresponding to the minimum specific energy is nothing but a critical depth. Now, my dear, if I say this is going to be critical depth, can I divide this curve into 2 parts? So d by dy will also give a maximum E. So how do you know that if E minimum is going to be here? Can you tell me what is E maximum over here? Whoever asked this question, can you tell me what is the E maximum over here? The maximum of E is going to be infinity. Is it going to be possible? Think and say, my dear. So simply asking the questions, first complete the sum. See, some of the people, means I don't say that asking of a doubt is a crime or sin. But the point is, I did not complete the entire topic. And meanwhile, some of the people are trying to see, don't listen to what I am saying just to ask the questions of mine. First, listen the total concept and understand it and try to analyze it. If you still have a doubt, then you can ask me. I don't have any issue to clear the doubts. But while I was delivering that, even means it was happened earlier also. I don't know what about the other subjects, but I do care about this. So when I am delivering the concept, you please try to focus on that concept, because if you are typing some doubt of yours, meanwhile I am going to discuss one more point, you won't listen that point, and again you will get doubt, and again you are going to ask, again you won't listen. This is a cyclic process, right? So why can't you make yourself to keep quiet for some time, and once I complete that topic, then you can ask me the doubt. Okay. So now, as it is a critical depth, now I can divide the curve into two portions. If I divide the curve into two portions, now based upon the critical depth, whenever the depth is going to be more than the critical depth, I can say the flow is going to be subcritical flow. Have you remembered that? So when do you say subcritical flow? Larger the depth, lesser the velocity. Larger the depth means compared to what depth it is going to be larger. If the depth is more than the critical depth, if the depth is going to be more than the critical depth, what is that? Yeah. So now, my dear, you see, when do we say subcritical flow? When the depth is going to be more than the critical depth, then we say it as a subcritical flow. And when the depth is going to be less than critical depth, we say it as a supercritical flow. Yeah. So point number 3. Point number 1, E versus phi. Point number 2, critical flow occurs at the specific energy. Now I am going to divide this into above subcritical, below supercritical. Above subcritical, below supercritical. Now you see, in this case, subcritical and then supercritical. Point number 3. For any specific energy other than E minimum, let me take any specific energy other than E minimum. So this is a specific energy other than the E minimum. Now, if I drop a line for this, now you see, you know, this is a specific energy other than the minimum specific energy. For any specific energy other than E minimum, if you drop a line, this line will touch us at 2 points on the specific energy curve. Yes or no? This line will touch us at the 2 points on the specific energy curve. And 1 point is going to be corresponding to the depth on the subcritical flow. Let's take it as a Y1. And the other point is going to be corresponding to the supercritical flow. Let's take it as Y2. So what is Y1 and Y2? You please observe here, for any specific energy other than E minimum, there exists two depths, and these two depths are known as alternate depths. So whenever the specific energy is same, and if one depth is going to be subcritical and other depth is going to be supercritical, we are going to say it as alternate depths. What do we say? Alternate depths. So now you please look over whatever this point here is. This is going to be the minimum specific energy, and I told you that is nothing but a critical flow, and I can write it as EC. What is EC? Critical specific energy. And whatever the magnitude, see the ordinates over here, this is going to be YC, and whatever this value is going to be VC square by 2G. Vc square by 2g. And above the critical flow, above the critical depth, you see above the critical. So whatever this ordinate is going to be y1 and velocity is going to be v1 square by 2g. So above the depth is more, velocity is going to be less. You can observe this variation, right? I hope you can able to see. You can see this portion is going to be decreasing. Yes or no? What is the meaning of decreasing? Velocity is going to be decreases. In the case of subcritical flow, velocity is less, depth is more. But in the case of the supercritical flow, if you observe this ordinate, this is y2, and this whatever this angle is going to be 45 degrees, right? So if it is y2, then this value is also going to be y2. Yes or no? So now from this, I'm going to write a few points. Points to remember. Point number 1. E curve represents variation of E versus Y for a given discharge. For a given discharge. And point number 2. Critical flow occurs minimum specific energy and depth corresponding to it is critical depth YC. Critical depth YC. So critical flow occurs at a minimum specific energy and depth corresponding to it is going to be critical depth YC. And point number 3. For any specific energy E other than E minimum, So for any specific energy E other than E minimum, there exists two depths known as alternate depths. So there exists two depths known as alternate depths. Sir, what are these alternate depths? One should be subcritical, other should be supercritical. Sir, where do we see this alternate depths? Now, example I will give you. The example is, if channel bottom is horizontal, so bottom is going to be horizontal frictionless. There is a frictionless, and let's say there is a sluice gate. So as now, my dear, listen to this point clearly. For any specific energy other than E minimum, there exists two depths known as alternate depths. I said, right? And now, if you see, this is the upstream water level, and this is the downstream water level. Okay. Forget about the hydraulic jump. After this one, the hydraulic jump is going to be happen. Okay. So whatever, this is nothing but a sluice gauge. Now, everybody, question number 1. Does the channel bottom is going to be rises or falls? Anything is happening over here? Does the channel bottom is remaining horizontal or rising or falling? The channel bottom is going to be horizontal. When the channel bottom is going to be horizontal, you tell me, observe this point and where is it? Yeah. Yes. When the channel bed is going to be remain horizontal, the total energy line, this is going to be the total energy line, and the specific energy is going to be same or not? So You see. So I'm going to take the channel bottom as horizontal, and whatever this dotted line represents the total energy line. This dotted line represents the total energy line. So in this case, in this total energy line, now you see, let's take for here, from here to here, whatever this is nothing but a specific energy E1, and whatever this is nothing but a specific energy E2. So both the specific energies are same. Both the specific energies are same. Yes or no? Whenever the specific energies are same, the depths are corresponding to the same specific energy. For any specific energy other than E minimum, there exists two depths known as alternate depths. So for this, let's take whatever the depth of flow here. This is going to be Y1, and here it is going to be Y2. So Y1 and Y2 here. Y1 comma Y2 are alternate depths. Why, sir? Why? For this depth to Y1, whatever the specific energy, for this depth to Y2, whatever the specific energy, both are same. So Y1 and Y2 are the alternate depths, where Y1 is subcritical, whereas Y2 is supercritical. Now, if you still have any doubts, I can say further. Sir, how come you say this is going to be subcritical, sir? Sir, what is the velocity head here, sir? This is V1 square by 2g. And what about the velocity head here, sir? Here it is going to be V2 square by 2g. So now, my dear students, what is E specific energy means? You know that specific energy means Y plus V square by 2g. Yes or no? From the total energy line to the channel bed, whatever this is nothing but specific energy, both the specific energies are same. And in the E1, velocity is less, depth is more. Velocity less, depth more, subcritical. In the E2, velocity more, depth less, supercritical. So Y1 is going to be subcritical, Y2 is going to be supercritical, and both are depths are corresponding to same energy. So now let's go back to the here E1 comma E2. If I plot over here E1 and E2, so both are going to be same. For that there must be one depth subcritical, other depth is going to be supercritical. So I can say for any specific energy other than E minimum, there exists two depths. So this is example number one. Not only this one, you can take one more example. You can see whatever the sluice gate, right? I have means if this is over here, Rogi spillway. This is channel bed. So channel bed is going to be horizontal. Let's assume this is frictionless. If it is going to be frictionless, now you know whatever this is nothing but the total energy line. Whatever there is nothing but total energy line. So flow will passes over here. And then it starts to rise, and somewhere it is going to be cause the hydraulic jump. Up to hydraulic jump, we are not discussing the hydraulic jump. So you see whatever the specific energy here, this is E1, and here also it is going to be E2. Both are same, but what is the depth of flow here? This is Y1, where is a subcritical flow, and here it is going to be Y2. This is going to be the supercritical flow. So I hope you understood. Whenever I assume the channel bed as horizontal and frictionless, the specific energies are same, simple as that. So I hope you understand this. So these are the practical approaches. One is going to be sluice gate, upstream and downstream of a sluice gate. Other one is going to be upstream and downstream of pressures. So both are going to be exit. Here and here, you can see in both the cases, this case 1 and this is going to be case 2. In both the cases, E1 and E2 are same. So these depths are going to be corresponding to same energy. So I can call it as alternate depths. So I have explained 2 points. One is a critical flow occurs at a minimum energy. This is the proof. And other one is for any specific energy, alternate depths. So these are going to be the practical scenarios where you are going to observe that. Sluice gate means to control the flow, my dear. We cannot plot the, see, sir, the critical depth is going to be somewhere in between. The critical depth is going to be somewhere. The critical depth may be somewhere in between because we cannot see the critical depth. So this is the critical depth somewhere in between. So above YC, above Y1, below YC, Y2. Okay. So now, apart from this, you come to the graph again. Listen to me carefully. Now the last point I want to say here is, does this E curve is going to be, does the E curve is going to be touches to the potential energy line? When the E curve is going to be touches to the potential energy line, what happens to velocity? When does E curve is going to be touches to the potential energy line? Tell me. If the E curve is going to be touches the potential energy line, then the velocity is going to be zero. When the E curve is going to see whatever this magnitude is nothing but velocity head man. If E curve is going to be touches to the potential energy line, then velocity head is going to be zero. When velocity is going to be zero, when depth is going to be infinity. When velocity is zero, when depth is going to be infinity. Is it going to be possible? No. So the E curve, whatever the upper limb of the E curve, so this E curve has two limbs, and this E curve can be divided into two portions, upper limb as a subcritical, lower limb as a supercritical. In E curve, the upper limb is going to be asymptotic to potential energy line. We call it as asymptotic. So what is the meaning of asymptotic? It seems to be horizontal, sorry, it seems to be touching, but it won't touch. The E curve seems to be touches the potential energy line, but it won't touch. Do you think it will touch like this? No, because when it touches, the velocity is going to be zero. It is not going to be possible. Similarly, now coming to the x-axis, do you think the lower limb is going to be touches to the E? Do you think the lower limb is going to be touches to the E? When lower limb is going to be touches to the E, then what is y value? When lower limb, see, think and say, if this is going to be touches to the E like this, then what is y value? 0. What is the meaning of y0? No flow. What is the meaning of infinity? Does not exist. When the E curve touches to any one of the axes, flow is not going to be possible. So my dear students, you see the E curve will not touches to the potential energy line and will not touches to the E axis. So the upper limb of the E curve is going to be asymptotic to potential energy line. The meaning of asymptotic is it seems to be touches, but it won't touch. And the lower limb of the E curve is going to be asymptotic to E axis. So the last point over here is in E curve, upper limb or upper portion is asymptotic to potential energy line, and lower limb is asymptotic to E axis. So these are the major points that we require from the potential energy, means specific energy curve. In ESE 2020, they have asked two questions from the specific energy curve itself. And mind it, this is very important. This is very important. So please have a look once. And now, after all, I'm going to give a conclusions as. You please go over the conclusions here. Now I'm not discussing everything. Okay. So E and Y conclusions are this is EC or E minimum. This is going to be YC and above, sub and super. Yes. Now think and say. In the case of the subcritical zone, this is subcritical, right? In the case of the subcritical zone, does the E curve is going to be rising or falling? Does the E curve is going to be rising or falling? Think and say. The curve is going to be rising. Yes or no? What is the meaning of curve is going to be rising? As a specific energy increases, the depth of flow. As a specific energy increases, the depth of flow is going to be increases. Yes or no? As a specific energy increases, the depth of flow is going to be increases. Yes or no? So in the case of the subcritical flow, if the approaching flow is going to be subcritical, so conclusions are, if the approaching flow is going to be subcritical, if approach flow is going to be subcritical, then I can say as a specific energy increases, the depth of flow is going to be increases and vice versa. What is mean by vice versa? If a specific energy decreases, depth of flow is going to be decreases. In simple words, I can say if approaching flow is going to be subcritical, graph is rising. Yes or no? Rising means are directly proportional to each other. If specific energy increases, depth of flow is also going to be increases. Finally, I'm giving you conclusions. What is happening when specific energy increases? If the flow is going to be subcritical. Similarly, if the flow is going to be supercritical, in the case of supercritical flow, now come on, think and say, if it is a supercritical, what may happen? Does the graph is going to be directly proportional? See, is it falling or rising? Falling. What is the meaning of falling? The meaning of falling is for the same magnitudes, you see, for the same magnitude as specific energy increases, the depth of flow is going to be decreases. As specific energy increases, depth of flow decreases and vice versa. See, the arrow mark I am representing upward is nothing but increases, downward is nothing but decreases. So with these points, I can say from the graph directly subcritical flow, the curve is going to be rising. Supercritical flow, the curve is going to be falling. In subcritical, rising means directly proportional. In supercritical, falling means inversely proportional. If you have understood this, I hope you understood this point. Now, have a look, please. You please have a look once again. This curve, these points. I'm going to ask you one question now. I'm going to ask a question now. Yeah. What is the purpose of this specific energy curve? Mr. Sanket Jain, how can you explain how you draw E curve? Because I have explained much more. You please go through the notes. See, that's a merging of the graphs. That's a merging of the graphs. If approaching flow is critical, then if approaching flow is going to be critical, then what happens? The energy is going to be critical flow, right? For the approaching flow is going to be critical, the energy is going to be minimum. So you cannot see the critical flow. In reality, critical flow does not happen. The flow is going to be either subcritical or subcritical. But in order to define the subcritical and subcritical, you require a medium known as a critical flow. And whenever the critical flow occurs, the flow is going to be stops there. Yeah, I hope. My dear, it's merging means see, this is a potential energy and this is a kinetic energy. If you merge means potential energy plus kinetic energy, both should be there or not. Whatever this line represents, only potential energy, and for the kinetic energy I have to represent on the other side. Okay, fine. Now let's go back to the, this is a transition I have given, right? This is the transition I have given. Okay, now my question is, if the approaching flow is going to be subcritical, think and say if the approaching flow is going to be subcritical. So I'm going to provide this. Yes. Question for you. Question for you. A subcritical flow is passing through a channel. A local bed rise cause water surface to A fall, B rise, C remain same, and D cannot say. So this is my question. Think and say. A subcritical flow is passing through a channel. A local bed rise causes water surface to. A local bed rise causes water surface to. Cannot say. Mr. Suresh Kumar Reddy is saying cannot say. Okay, rise, and everybody is giving all the options. Rise, same, false, and cannot say. Mr. Suresh Kumar Reddy. Somebody is asking, sir, why at the critical flow is going to be stopped? Because it reaches the minimum energy, my dear. If you don't have means once you reach the minimum energy of yours, can you move forward? No, right? What is the minimum? What is the critical flow? Critical flow is the flow at which energy is minimum. Specific energy is minimum. See, what is the answer for this is, look, a subcritical flow is passing through a channel, a local bed rise. What is happening when the bed is going to be rises? See, in simple words, when bed is going to be rises, what happens? When bed rises, specific energy decreases. Yes or no? Yes or no? So when bed is going to be rises, for this solution, when channel bed is going to be rises, when channel bed is going to be rises, whatever, this is nothing but the total energy line. So when channel bed rises, this is E1 and here it is going to be E2. So E2 is going to be less than E1, which means specific energy decreases. Okay, and now this is point number 1. Point number 2, from E curve in subcritical zone, if the approaching flow is going to be subcritical zone, so now from the E curve, you go for the E curve, it is going to be rising. See, this is going to be directly proportional. So from E curve, as specific energy decreases, depth of flow is also going to be decreases. So water level falls. Water level falls. So directly proportional, right? That also directly proportional. I hope you can understand this one. So now see, I have represented with the points. So water level is going to be false means answer is going to be fall. Water level is going to be fall. So why, sir? First of all, see, do I know exactly water level is going to be rise or falls at first? Before knowing this concept, I have given this figure and I asked you, this is a rise, right? So, and I asked you, we never know whether the water level rises or falls. But now, from the specific energy concept, what we got to use, this is a channel bed rise, specific energy decreases. And if the flow is going to be subcritical, then from the specific energy curve, in the zone, from the specific energy curve in subcritical zone, as a specific energy is going to be decreases, depth is also going to be decreases, which means water level will fall. Okay. So I hope you understood the meaning behind it. So similarly, you can frame 4 more questions. You can means 3 more questions. Now, I'll ask you one more question now. So you please tell me. Listen to the question carefully. A rectangular channel is carrying a supercritical flow. A rectangular channel is carrying a supercritical flow. If the channel bed falls by delta Z, then water surface will. Options are same options I am providing you. A rectangular channel is carrying a supercritical flow, and if the channel bed drops or a local drop of channel bed causes water surface. Come on, tell me. So now people are coming to the track. Yes. So what is going to be happen? It's going to be fall. As simple as that, right? So I'm giving you now the flow is going to be supercritical, and I'm saying you the channel bed is going to be drops. When the channel bed is going to be drops, so simply deeper the channel, higher the specific energy. So if the channel bed is going to be drop, specific energy is going to be more. And as the flow is going to be supercritical flow, in the case of the supercritical flow, the graph is inversely proportional. Yes or no? So the meaning of inversely proportional is as a specific energy increases, the depth is going to be decreases. So when channel bed drops, specific energy will increase. And in the case of the supercritical flow, when specific energy increases, depth will falls. So for the same question, the answer is going to be false only for supercritical flow. I hope you understood the discussion regarding to this. Yes. If you have understood, then let's see the other transition now. Let's see the one more transition. So now, so far and so good, whatever the transition I have made. So far and so good, whatever the transition I have made is a channel bottom rise or channel bottom drop. So, but before you said it may rise or fall, no, sir. My dear Palder Yashwant Sai Prashant, before I said it may fall or it may rise because I don't know the concept. But now I said, now what is the concept behind it? So once you know the concept behind it, you can say the answers. Okay. So now let's see the one more transition, because I am going to draw one more curve. So let's see that one more transition, second transition. So far and so good. I have discussed about channel bottom rise and channel bottom drop only. Now, so there is a one more transition. Coming to the width transition. Coming to the width transitions. Okay, so in the case of the width transition, in the case of, okay, fine, let's forget about this one. I'll draw something and then I'll explain based upon that. Okay, so far and so good. Whatever the discussion I made is for the channel bed rise or channel bed drop. Yes or no? Have I discussed anything regarding to the width? Have I discussed anything regarding to the width? No, I kept the width as a constant. I kept the width as constant. Now I am going to do, so I am going to do change in the width. Now, how, sir? Look, when the stream is going to be passing, when the stream is going to be passing like this, at some point of time, the width may gets increases. When the stream is going to be passing like this, at some point of time, you can observe the width may increases, and at some point of time the width may decreases. This is a stream, a flow of water. I hope you can imagine this. Yes, whenever there is a change in the width, you see here the width of the flow is going to be 1, here the width of the flow is going to be 2, here the width of the flow is going to be 3. So in the plan view, if you can observe the plan view, when it is going to be happen, let's take this is crop 1 here, and this is going to be crop 2. In between, this is a canal. So especially in the case of rivers, you see that the widths are going to be continuously changing. This is nothing but the width transition. This is nothing but the width transition. And whenever the width is going to be changes, what happens to the water surface? Come on, let's see that. Okay. So there is no change in the channel bed now. The channel bed is going to be same. Yeah. So no change in the channel bed. Now, but in the plan view, this is longitudinal section. Yes. In the plan view means in the top view. When you allow the flow, so let's say here this is the depth of flow, and when you allow the flow, initially the width of the river or canal is going to be having like this. Okay. Now, when the width is going to be at some point of time, the width has been reduced. At some point of time, the width has been reduced for the sake of, let's say, for the sake of to protect the banks. So the width got reduced like this. So now this is a plan view, my dear. And see, while I'm changing the width, am I changing it directly, means suddenly, or smooth transition? It is going to be a smooth transition, right? So now here the width of section, here it is going to be B1 and here it is going to be B2. Is there any change in the channel bed? This is a channel bed. And you know this is going to be the top view or plan view. You can see the plan view. Now, whatever here, this is nothing but a, what is this? total energy line. Okay. So now my question is, so if this is the case, in reality, I am not changing the channel bed, but there is a channel transition as a width transition. So width is going to be changes from one width to other width. See, I am taking here as width is going to be decreases. You can take as a width increases also. So now let's say here the depth of flow. This is the depth of flow. So this is going to be y1. Now you know that up to this point, the width is going to be same. The width is going to be same. So you know that up to this point, the depth of flow is also going to be same. Yes or no? Any change, please? Is there any obstruction? No. Up to this point, the flow is going to be uniform. Very well and good. Now, there is a transition. And now this is the zone of transition. What is this? This is the zone of transition. So what transition we are going to see over here? Width is going to be decreases. Can I say the transition is nothing but a width reduction? And whenever the width is going to be reduces, now you tell me, do you think the water surface is going to be same? Let's say with the known concept, let's apply. Whatever the known concept so far. I just created this specific energy curve. I just created the specific energy curve. Think, please stop your questions and means first listen. Listen and then now let's see from the given details. I don't know anything extra. I know only the specific energy curve. Okay, let's draw the specific energy curve on the side also. Let's draw the specific energy curve on the side. I'm drawing the specific energy curve. So whatever, this is nothing but the specific energy curve. Okay. Now, let's say the approaching flow is going to be subcritical itself. Let's say the approaching flow is going to be subcritical itself. You see, before the transition, whatever the specific energy, this is the specific energy E1. After transition, whatever the specific energy E2. Before the transition, see, this is a transition zone, right? Yes. Whatever, this is nothing but the transition zone. So in the transition zone, what is happening? In the transition zone, what is happening? So you just have to look over in this transition zone itself. So now, my dear, before the transition and after the transition, specific energy is going to be same. Yes or no? Now, so far and so good. In the previous cases, whatever explanation I mentioned, okay. So when specific energy changes, the depth is going to be changes. I can say that. But now, in this case, specific energy E1 and E2 both are same. When specific energy E1 and E2 both are same, I am discussing about subcritical flow or supercritical flow. Subcritical flow. And both are going to be touches at same point, are they? Remember E1 and E2, see, for the subcritical flow, because I have to look over the subcritical zone above, and for E1, this is Y1. For E2, this is Y2. Both are going to be same. So if I use the specific energy curve over here, as there is no change in the channel bed, specific energies are going to be same. When the specific energies are going to be same, think and say, when the specific energies are same, no change in the specific energy, in the subcritical curve, no change in the depth, which means according to the specific energy curve, the water level should be like this. According to the specific energy curve, after the transition also, the depth is going to be y. But is it possible? Think. Is it possible? No, because there is a transition. What transition this is? This is a width transition. Have we taken care of the width transition in the specific energy curve? No. Keep that in your mind. Specific energy curve is suitable when there is a channel bottom transition. means when channel bed rise or when channel bed fall. Repeating the point again, if the channel bed is going to be horizontal and when there is a width transition, if you see the specific energy curve, according to the specific energy curve, before the transition and after the transition, the specific energies are same. Specific energies are same. When the specific energies are same, then the depths are also going to be same. But is it possible? No, this is not true. This is not going to be true. So specific energy is not going to be suitable. Here you cannot use the specific energy curve. Specific energy curve cannot be useful in the case of the width transition, because when there is a width change, when there is a change in the width, either the water level may rises and then it becomes like this, or the water level may falls and then becomes like this. Okay, so in the transition zone, either it may rise or it may falls. But if you use the specific energy curve, according to the specific energy curve, Y1 and Y2 both are same. Is it going to be possible? No. So I hope you understood the difference between the channel bottom transition and channel width transition. In the channel bottom transition, you can use a specific energy curve. Sir, then sir, if there is a width, sir, then what to do, sir? Now, there comes. Please keep this aside. I'm going to explain this thing again later. Okay. So now how to analyze this one? How to analyze this one? Our thinking is different and reality is different. Okay. I don't know, too many answers came, so that's the reason why. Okay, it's done. Now, what we are going to discuss is the same specific energy, from the specific energy. What is specific energy? Y plus V squared by 2G. So now the other topic is Y plus V squared by 2G, and from this I can rewrite E is nothing but Y plus Q squared by 2G A square. And you know, let's apply this for the rectangle. In the case of the rectangle, you know that area is nothing but B into Y. So E is nothing but Y plus Q squared by 2G B square Y square. And I can write this as Q by B as a small q. What is meant by Q by B, sir? So I can write this Q by B as a small q. What is mean by small q? Means discharge per unit width. What is that? Discharge per unit width. So now listen to me carefully. I am not saying discharge. I am saying discharge per unit width. Discharge per unit width. So now if you substitute over here, E is nothing but Y plus E is nothing but Y plus. So Q by B, small q square by 2G Y square. 2G Y square. Okay. So now you take this Y to the other side and the Q to the one side. E minus Y. Yes or no? E minus Y and into 2G Y square. E minus Y into 2G Y square. So can I write this one as Q is equals to root of E so I can write this one in the form of root 2G into root of E Y square minus Y cube. Can I write like this? Think and say, can I write this form? So in the case of the rectangle, I can write this in terms of so e minus y, and you send the y square to the other side, ey square minus y cube, and you send 2z and you apply the root. So now what I am going to do here is by using this equation, I am going to draw one more curve. By using this equation, I am going to draw one more curve. What is this curve, sir? Let's see. So keep this equation, and from this equation, our point is we need to study the width transition. What is this? This is a width transition. So width reduction, I want to study the width reduction or width expansion. So for that, I am going to draw one more curve. That curve is known as discharge curve. Discharge curve. Okay. So what is this discharge curve? Listen to me carefully. It is also known as a Q curve. It is also known as Q curve. Okay. So when a Q curve is going to be there? Now, listen. From the equation, Q is equals to root 2g into root of ey square minus y cube. Ey square minus y cube. Now, I am going to take that transition. So whatever the transition, this is going to be the width reduction. This is B1 and here it is going to be B2. Okay. And this is channel bed. This is a channel bed where you can see this is nothing but the total energy line. And at this point here it is going to be E1 and at this point it is going to be E2. So this is plan view and this is going to be the section view. We cannot use the section view. Yes. Or I can write so this is the total energy line, and whatever this is nothing but initial depth of flow. Let's take the initial depth of flow of water is going to be y1. Okay, so now which is constant, which is variable? What is a small q? Small q is nothing but discharge per unit width. Yes or no? Come on. Whenever there is a change in the width, then q is going to be changes. Yes or no? Whenever there is a change in the width, then q is equals to changes. If width is going to be decreases, you know that q is inversely proportional to b. Yes or no? Now, because capital Q is going to be constant, small q is inversely proportional to b. As width is going to be decreases, discharge per unit width is going to be increases. Accept or not? Yes. So discharge per unit width is going to be increases. Now come to this equation. In the equation, from this condition, you see before the transition and after the transition, specific energy is going to be same. E1 is equals to E2, which means specific energy is going to be constant. Yes or no? Keep that in your mind. In this equation, what I am doing now, E is going to be constant. Why? Because when I am discussing the channel width transition, I am going to keep the channel bottom as horizontal. When I keep the channel bottom as horizontal, then the specific energy is going to be constant. So from this, can I write for a given upstream specific energy, because E is going to be constant. E is going to be constant. Then can I write Q is a function of Y? You see this equation and tell me. So for a given upstream specific energy, Q is a function of Y. I can say that. You have any doubts with this? I just modified this equation. I take the same equation, but I modified this equation for rectangle. And keep that in your mind. This curve is going to be suitable for only rectangle, because the transitions we are going to discuss now, those transitions are for rectangular channels only. Whatever the transitions I'm saying, width reduction, width expansion, channel bed rise, channel bottom drop. So those are, we are going to discuss for the rectangular channels only. This is just a starting of the transition. Now, in this equation, can I say this equation represents the variation of Q versus Y for a given upstream specific energy. Now think carefully. Whenever the discharge per unit width changes, discharge per unit width changes. If Q changes, depth is going to be changes. Now you tell me, do you think water level is going to be constant? No. The water level may rise or may fall. Yes. So the water level may rise or may fall. From the equation, I can say this is going to be gives the variation of Q versus Y. Now, draw that variation, please. On x-axis, this time I know Q, because when width is going to be decreases, discharge per unit width is going to be increases. On y-axis, it is going to be Y. Now, as you know, Q is a function of Y. Now, please substitute when y is 0, what happens? I want to draw the graph. Think and say. When y is equals to 0, what is going to happen? If I keep y 0, if I keep y 0, then what is going to be happen? If I keep y 0, 0 minus 0, then it is going to be 0. So Q is going to be 0. So the graph is going to be start. If I keep y 0, then Q is also going to be 0. Okay. The graph starts with, if there is no flow, what does it mean by y 0, Baba? There is no flow, then there is no discharge per unit width, right? If there is a flow, then no, there is a discharge. No discharge, no flow, no depth. Y 0, Q is equals to 0. Now, in the same equation, if I keep the y as a E, if I keep y as a E, so y 0, no flow, then Q is equal to be 0. Okay. Now, y is equals to specific energy. When y is equals to specific energy? When y is equals to specific energy, when y is equals to E1, when y is equals to E1, because what is the E value? When y is equals to E1, the velocity is equals to 0. When velocity is equals to 0, then discharge per unit width is also going to be 0. Yeah. So when y is equals to 0, no flow, then discharge is also going to be 0. Okay. Understood? When y is equals to E1, what is the meaning of E? E is nothing but y plus v square by 2g. So when can I write E is equals to y? If I write v0, then only y is equals to E1. So if v is equals to 0, then no flow. When there is no flow, then the discharge per unit is also going to be 0. See, I am constructing the graph over here. When y0, Q is going to be 0. And when y is equals to upstream specific energy, if you substitute y is equals to E1, E1 into E1 square, E cube, yes or no? Just substitute y is equals to E. So E cube minus E cube minus E cube, 0. Then velocity is 0, then no flow. So in both the cases, Q is equals to 0. When Q is 0, Y 0. When Y is equals to E1, when Y is equals to E1, then also the Q is equals to 0. So Q0 means that the points are locating on the Y axis. Okay. Y0, Q0. Y is equals to E1, Q is equals to 0. And the graph should start with the origin and ends with this point. Then when it is going to be happen? When the graph is going to be first rises and then decreases. The graph is going to be looks like this, because these two are the extreme conditions. These two are the extreme conditions. So no flow, no flow. And in between the graph is going to be, see, the graph should looks like this only, and it should be false on the positive coordinate. So if that is the case, from minimum and maximum, I can draw the graph in this fashion. So don't ask me, sir, how you have drawn the graph. I have given these points. So when y is equals to E1, Q is equals to 0. When y is equals to 0, Q 0. Y 0, Q 0. Y is equals to E1, Q is equals to 0. And now, whenever you see this graph, and you see this must be having some maximum R naught. So whatever this value, this is going to be the discharge per unit width. Maximum discharge per unit width. Q maximum. So, and the depth corresponding to the maximum discharge per unit width is going to be the critical depth. If you want to go for that, for Q to be Q max, dq by dy is equals to 0, you are going to end up the condition is q squared by g is equals to aq by d. I'm telling you, if you solve that, you are going to end up this condition. Whenever the condition comes into the existence, then that is going to be the critical depth. See, it is just exactly opposite to the, E curve R naught. So from the discharge curve, means how I am drawing the discharge curve for the width transitions, whenever the specific energy is going to be constant, because chala bottom horizontal, so I am making E as a constant now, and I am varying whom? Discharge per unit width. When the discharge per unit width is going to be changes, the depth of flow is also going to be changes. And when the discharge per unit width becomes maximum, then the depth becomes a critical depth. And above it is going to be subcritical, and below it is going to be supercritical. Above subcritical, below supercritical. So again, let's represent some of the points. Points to be remembered. Okay. Point number 1. Q curve represents Q versus Y for a given upstream specific energy, which means the specific energy should remain same. So this curve is going to be used whenever the specific energy is same, because this curve is going to be used when the channel bottom is horizontal. This curve is going to be used for Q curve. Q curve is going to be used when channel bottom is horizontal. When channel bottom is horizontal, specific energies are constants. Then only you can use the Q curve. Okay. So now, point number 2. Critical flow exists at Q. Critical flow exists when Q becomes Q max and depth corresponding to it is critical depth YC. Okay. So now one more point. When does the critical flow occurs? When the energy becomes minimum or discharge per unit width becomes maximum. So if the critical flow means if the energy is also minimum, then also you can say critical flow. If the discharge per unit width is going to be maximum, then also you can say it as a critical flow. So both represents a critical flow. And now point number 3. Again, you see, for any discharge per unit width, other than the Q maximum. I'm just replicating the points with the earlier cases. So in the case of the E curve also, third point, for any specific energy other than E minimum. Now, for any discharge per unit width other than Q maximum, there exists 2 depths. And this depth is going to be Y1 and this depth is going to be Y2 for a given upstream specific energy. Now, my dear, specific energy is going to be same or not? Because I am saying the given specific energy. Specific energy is same. and y1 and y2 are the depths corresponding to same specific energy. Whenever the depths are corresponding to same specific energy, then I can say it as alternate depths or not. What are the depths corresponding to same specific energy? Alternate depths. For any discharge, Q other than Q maximum for a given specific energy, there exists two depths known as alternate depths. Known as alternate depths. So point number 1, point number 2, and point number 3 known as the alternate depths. So these are the points that need to be remembered. So now the conclusions are. You see, this is going to be the discharge curve. Above subcritical, below super critical, and this is Q, and here it is going to be Y. This is YC. Okay. So now the conclusions are: if the approaching flow is going to be subcritical, come on, my dear. If the approaching, see just how I have explained the conclusions of the specific energy curve. Similarly, I am going to explain the conclusions for the discharge curve. So now you see, in the case of the discharge curve, if it is going to be subcritical, now what is this curve represents, my dear? The curve represents, is it falling or rising? Is it going to be falling or rising? Falling, because as a Q increases, depth is going to be decreases. Yes or no? So as a Q increases, the depth is going to be decreases. So in the case of the subcritical flow, as a Q increases, the depth of water level decreases, and vice versa. Because this is going to be the falling, right? Falling means inversely proportional. Okay. And if the flow is going to be supercritical, now this is going to be rising, right? In supercritical, it is rising. As discharge per unit width increases, depth of flow increases, and vice versa. Look, this curve is exactly opposite to E curve. E curve looks like this, and discharge curve looks like D shape. E curve looks like C shape. C shape is a E curve. D shape is a discharge curve. Okay, and whatever the conclusions we got is a completely opposite. So completely opposite. Now, let me go with the question. So I hope you understood the conclusions here, please. If you have any doubts, please let me know. So at the end, what you need to look over here is, in subcritical flow, is it directly proportional or inversely proportional? I don't know what is happening, but some due to more number of questions have been asked. My screen space is going to be explain point number 3. For any discharge Q other than the Q maximum. See, this is a Q other than the Q maximum. For the given specific energy, for this Q at any point, for any Q, there exist two depths, right? What are the depths corresponding to the same energy? Critical depths, sorry, alternate depths. That's it. Now, let's go back to the condition. See, this is the condition, right? This is the condition. Now, come on. I don't know what is happening exactly over here. I don't know what is happening exactly over here. So I'm removing this. Okay, fine. Now, if the approaching flow is going to be subcritical, see, this is the condition I'm giving you. This is the condition I'm giving you this time. If the approaching flow is going to be subcritical, you know, means you don't know earlier whether the water level is going to be rises or falls. Now, this is going to be width reduction case. So, case is width reduction where B2 is less than B1. So, what is going to be happen? Does the water level, I want to you answer this one. What is going to be happen? Does the water level rises or falls? Think. What is going to be happen here? Can I use a specific energy curve? No. We have to use the discharge curve. From the discharge curve, as you know, Q is going to be inversely proportional to B. Q is inversely proportional to B. So Q is going to be inversely proportional to B, which means Q2 is more than Q1. Q2 is more than Q1. So when the discharge per unit width is going to be increases, see, when width decreases, if the width is going to be decreases, discharge per unit width increases. And in the case of discharge curve, in subcritical flow, the graph is going to be falling graph. The graph is falling, right? When the graph is falling, if discharge per unit width increases, water level will falls. Yes or no? Water level will fall. That's what I said. So in subcritical flow, as discharge per unit width increases, the depth will falls. So for whatever this case, earlier I don't have any answer, but now I can say, okay, width is reducing, fine. Discharge per unit is going to increases, fine. Okay, discharge per unit width increases. Now, just let's go back to the discharge curve. In the case of the discharge curve, if it is a subcritical flow, the graph is falling. Okay, what is the meaning of falling? Inversely proportional. So, in subcritical, the graph is inversely proportional, which means if discharge per unit width is going to be increases for subcritical, if discharge per unit width is going to be increases, then depth is going to be decreases, which means it results in Y2 is less than Y1. Yes or no? If that is the case, then what happens to water level? Water level starts to fall. Water level is going to be falling. Now, this is Y2. I hope you got the meaningful. This is E2. I hope you got the meaning over here. So if this is the case in reality, then what is going to be happen? Keep that in your mind. If the flow is going to be subcritical, then only this is going to be happen. Okay. So I hope you understood this. If you have any other doubts, so you can say. So I'm creating a poll. So are you able to understand the subject or not? So why they are asking sign? Already you have signed, right? Why they are asking about signing? Okay, fine. I hope you feel less now. So you understood the concepts well. So I hope so, because if I want to create a poll also, they're asking something regarding to the sign or something else. Okay, let it be. It's not that much important. But because already flood of questions have been there. When I open the question and answer section, around 800 questions, means 700 questions were there. So I cannot go through all the 700 questions. Means still the numbers are counting, because if one person asks also. Okay, let it be. So that's about the discharge curve and specific energy curve. So at the end, the point is, see, these are the things that you need to look over carefully. So these conclusions are important. These conclusions are make sure everything. So if you understand that conclusions now, then fine. If you can understand the conclusions, then it is fine. So and now come to the last note points. Yeah. So as we have been discussed so far, how many things we discussed? Specific energy curve and discharge curve. Note. Specific energy E curve and Q curve are useful for flow analysis in channel transitions. In the case of the channel transitions, so we can find out, we can use this one, E curve and Q. See, this is just a starting of the flow curve. Okay. So E curve and Q curve, these are going to be just starting points, but we have to go for the too much of analysis. So that we'll be discussing in the later classes. But as of now, I hope you understood what is the meaning of the specific energy and what is the meaning of the discharge curve and how the flow is going to be changes in the case of the transitions. So these are the applications I said, right? Number one is to define the critical flow. Now you tell me. So what is critical flow? Critical flow is the flow at which specific energy is minimum or discharge per unit width is maximum. And in order to analyze the flow or transitions, I am using two curves, specific energy curve and discharge curve. Yeah. So now let's see some of the relations. Now, as I said you, the application, right? We are going to determine the determination of critical depth. determination of critical depth, or in other words, you can write it as analysis of critical flow. Okay. How we are going to do the analysis? So critical flow occurs when E becomes E minimum or EC, Q becomes Q maximum, and Froude number Fr is equals to 1. So whenever E becomes EC, Q becomes Q maximum, and Froude number is equals to 1, then we are going to say it as a critical flow. Yes or no? You can use any of these conditions. And what is the critical flow condition? Critical flow condition. So the meaning of critical flow condition is Q square by G is equals to A cube by T. Q square by G is equals to A cube by T. So now listen to me carefully. From this condition, what I am going to do is Q square by GA square is equals to A by T. Can I write like this? Q square, so let's take A square to is here. Q square by A square is equals to A cube by T, and Q square by A square means V square by G is equals to A by T means D. Yes or no? Yes. And as we are discussing about the critical flow, then the velocity is going to be the critical velocity. Then the velocity is going to be the critical velocity. Okay. So now divide with 2 on both sides. If I divide with 2 on both sides, see from this condition, I am creating a one equation over here as from this condition. You see Vc square by Z is equals to D. Now divide with 2 on both sides. If I divide with 2 on both sides, Vc square by 2G is equals to D by 2. What is the meaning of Vc square by 2G? The meaning of Vc square by 2G is yet a critical flow, the critical flow condition, at a critical flow, the velocity head is a half of hydraulic depth. Yet critical flow, velocity head is half of hydraulic depth. So what is the meaning of the critical flow? Critical flow means whenever the specific energy is minimum, then we call it as a critical flow, and at that point whatever the velocity head is nothing but half of the hydraulic depth. So what is mean by EC, sir? No. You see, E is nothing but Y plus V square by 2G. Yes or no? Then EC is YC plus VC square by 2G. Okay. Now, then can I write this EC is nothing but what is VC square by 2G? D by 2. So now if you rewrite this YC plus D by 2. So by using these conditions, we are going to find out the critical depth in a rectangle, triangle and trapezoidal. I was saying about the critical depth, critical depth, critical depth. And if you know the critical depth, then only you can say whether it's subcritical or supercritical. Yes or no? If the depth of flow is more than critical depth, then you can say it as a subcritical. If the depth of flow is going to be less than critical depth, then you are going to say it as a supercritical. And I told you that analysis is based upon the specific energy. Yes or no? And from that, I got to know this Q squared by G is equals to A Q by T. So this is very, very important, and based upon this in GATE 2019 and 20 also they have asked a question. Yes, you see, this is GATE 2019 set 1 question. So in GATE 2019 set one question, in a rectangular channel, so they're asking the rectangle channel, the ratio of velocity head to the flow depth for a critical flow condition. So now you tell me, at a critical flow, just now I told you the velocity head Vc square by 2g is nothing but half of the hydraulic depth. Yes or no? In the case of the rectangle, the d is nothing but y. In the case of the rectangle, the d is nothing but y. And whenever it is going to be the critical flow, then this is going to be dc. Yes or no? Now Vc square by 2g, and they're asking a flow depth, right? By is equals to yc by 2. So from this, Vc square by 2g by yc is equals to 1 by 2. The answer is going to be C. So in a rectangular channel, the ratio of velocity head v square by 2g to the depth of flow. What is meant by depth of flow here? Y. So in the case of rectangle, the hydraulic depth is nothing but y, right? You remember that in the case of the rectangle, the hydraulic depth is nothing but y. So you substitute that, then the ratio is going to be 1 by 2, right? So the answer is going to be 1 by 2. This is GATE 2019 set 1 question. I just said this one just to make sure. So this type of questions can be expected. Yeah. So now, by using this analysis of critical flow, our main point is to determine the critical depth, because without critical depth, you cannot go further. You cannot go analysis of the GVF or RVF, means hydraulic jump or unsteady flow, anything. So now, how to determine the critical depth? In the case of rectangle, so in rectangle, again, whatever this is nothing but the depth of flow y, width is going to be b. Okay. So now, what is the critical flow condition? I am going to use only one condition, critical flow condition. From starting onwards, whenever I say critical flow, the critical flow condition is nothing but q square by g is equals to a cube by t, and it will come when the specific energy is going to be minimum. Okay. So now q square by g is equals to a cube by t. And you know that the area of the rectangle is going to be b into y. And at a critical flow, I am talking about the at a critical flow or not, y becomes yc. And now you please substitute over here, q square by g is equals to b cube yc cube by b. Out of this b's, 1b, and here is going to be 1b gets cancelled. And you know that small q is nothing but discharge per unit width or not. So from this, I can write yc cube is equals to, you send the b square to the other side. If you send the b square to the other side, capital Q square by b square, capital Q square by b square, which is nothing but small q square by g. And what is yc? Yc is nothing but q square by g whole to the power of 1 by 3. Yc is nothing but q square by g whole to the power of 1 by 3. This is a very important, because without this, you cannot analyze anything. And you must have to remember for the rectangle, what is yc? Yc is nothing but how to determine yc in the case of the rectangle. Just simply you apply the critical flow condition, that's it. In the critical flow condition, you apply the channel geometry details, then you can find out the yc. Once you know the yc, then you can find out ec. What is ec? Yc plus d by 2. In the case of rectangle, you know d is equals to y. Just now I said yc. So ec is equals to yc plus yc by 2. Then ec is equals to 3 by 2 yc. So in one of the examination in ESE, for a rectangular channel at a critical flow, the ratio of specific energy to critical depth. At a critical flow means specific energy is minimum specific energy, critical specific energy to the critical depth. EC by YC is equals to 3 by 2. See, it may seems like sir, too many formulas are there over here. No, you have to understand one thing. I'm going to rely on only this point. I'm going to rely on only this condition, and based upon this condition only, you see, based upon this condition only, and why I am deriving these things is based upon this condition only. I am saying velocity head is going to be half of the hydraulic depth. Based upon that condition only, I am saying YC and EC also. So now, similarly, you please solve for the triangle. In the case of the triangle. In the case of the triangle. So in the case of a triangle, area, what is area of triangle? My square. What is area of triangle? My square. And at the critical depth, y becomes yc. And what is the hydraulic depth of the triangle? Y by 2. In the critical depth, yc by 2. Again, apply the critical flow condition. Q square by g is nothing but. So I'm writing directly now. What is a cube now? A cube means m cube yc power 6 by t. What is the top width of the rectangle? In the case of the rectangle, top width is going to be 2my, and at a critical depth, 2myc. 2myc. So now here 1m, 1y. So then can I write directly yc is equals to, you send this 2 to the other side, 2q square. You send this m square to the other side, gm square, power 5, right? If it comes over here, whole to the power of 1 by 5. Whole to the power of 1 by 5. So yc is equals to 2q square by gm square whole to the power of 1 by 5. Okay. Similarly, what about EC? EC means yc plus d by 2, right? What is d value? Yc by 2 by 2, which means yc by 4. So which is going to be 5 by 4 yc. So 5 by 4 yc. This is actually d by 2, and that d by 2 is nothing but yc by 2. So now these are the critical flow conditions in the case of the triangle. And this triangle, it's up to you whether if you want to remember, else you know the procedure. What I have done here, I am writing the cross-sectional details and I am applying this in the case of the critical flow condition. So it's all about how we think and how we perspective. If you think these are just formulas, then it's up to you. But if you think these are the concepts, that's also up to you. Because I'm not introducing too many concepts and I'm making sure the conclusions at the bottom. So throughout this day, if you observe clearly, I'm using only one formula. E is equals to y plus v square by 2g. And from that only I have derived all these things. Yes, so whether to take it as a single formulas or individual formulas or whether to know it as a concept, it's up to you. I hope you understood all these things. So it's about our triangle, and the last one I'll say is for trapezoidal. Similarly, you can find out for the trapezoidal. But in the case of the trapezoidal, you please find out for half of regular hexagon. You please find out for the half of a regular hexagon. So in the case of half of a regular hexagon, now, so in the case of half of regular hexagon, area √3 y square, top width 4 by √3 yc, hydraulic depth 3 by 4 yc. These are the cross-sectional details. Now you please substitute q square by g is equals to a cube by t. A cube means √3 cube, 3 √3 yc whole to the power of 6 by top width 4 by √3 yc. Now, you please from this point, yc 1 by c power 5, 4 by root 3. If it goes to the numerator, 3 root 3 into root 3, root 3 into root 3, 3, right? 3 into 3, 9. This 4 go to the other side. Then finally, yc is equals to 4q squared by 9g whole to the power of 1 by 5. 4q squared by 9g whole to the power of 1 by 5. And EC is equals to YC plus D by 2, right? So EC is equals to YC plus D, 3 by 4 YC by 2. 3 by 4 means 3 by 8. 1 plus 3 by 8, then finally EC is equals to 11 by 8 YC. Do you need to remember all these things? I say don't remember this. See, why I have given this condition is just for an exercise for you. Just for an exercise for you. So whatever they give you, you know how to determine the area, how to determine the top width, how to determine the hydraulic depth. Don't you? That is the reason why I told you in the starting classes, channel geometry is very, 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 very important. If you take it lightly, they will take you lightly. So that's how with this critical flow, and still some things are going there, and that we'll be seeing tomorrow, because I'm going to conclude these things. I'm going to intermix all the topics. So as of now, I have discussed only one application of the specific energy. That application is a critical flow only. So I have find you what is how to determine the critical depth and all those things. But we'll see the remaining things tomorrow. But you please go through the notes once again. So these are very, very important topics. Without these things, so we cannot go further for the tomorrow's class. So for tomorrow's class, before you come to the tomorrow's class, be prepared for all these things. Okay. And I am enabling a doubt clearing session. It's already 12:45. Those who wants to attend the doubt clearing session, they can be, else you can leave. Mr. Reddy Bhattini Narendra, please speak out.
Sir, can you open slide number 71, sir?
Tell me.
Sir, in this, we have wrote E2, no, sir?
Yeah.
E2.
Yes.
E1 is equal to E2 plus delta Z.
Yes.
There E2 is specific energy, sir.
Yes, E is specific energy. E represents specific energy.
E2 plus delta Z means total energy, sir.
Yes, very good. That's it. Yeah.
And slide number 70. 1 minute, sir. Slide number 79, sir.
This one?
Yes, sir.
Yeah, tell me.
Sir, can I talk in Telugu, sir?
Yeah, you can.
Sir, ikkada width reduction jarigindi kada, sir.
Yes.
Ikkada specific energy E1, E2 rendu okate unnai, Y1, Y2 kuda rendu okate unnai kada, sir.
ఎలా ఉంటాయి? ఇప్పుడు నీకు E1, E2 ఒకేలా ఉన్నాయి, కానీ బట్ దేర్ ఇస్ ఎ ట్రాన్సిషన్, రైట్? విడ్త్ ట్రాన్సిషన్ జరుగుతుంది కదా.
అవును సార్, విడ్త్ ట్రాన్సిషన్ జరిగింది.
When there is a width transition, obviously water level should change.
అవును సార్, చేంజ్ కావాలి, కానీ ఇక్కడ ఎందుకు సార్ ఇలా ఉంది మరి?
That's why I'm saying na. See, in the case of width reduction, you cannot use a specific energy concept, means a specific energy curve is there, right? You can E curve for the analysis.
Okay, sir.
Reason why at first what I have done is, first I explained with the E curve. Yes?
Yes, sir.
And there I said that as E1 is equals to E2, from E curve it is going to be Y1 is equals to Y2. But in practically, do you think Y1 and Y2 both are same?
No, sir. They will not be equal.
Why?
Because there is change in width, no, sir.
Yes, that's it. So if there is no width reduction, then Y1 and Y2 can be same. But due to width reduction, Y1 and Y2 cannot be same. So as a specific energy is not following the concept, we are not using specific energy curve for width reduction. So that is the reason why we developed a new curve. What is that new curve? That is known as discharge curve. Okay.
Okay, sir.
So based upon the discharge curve, what we can say is, as the width is decreasing, I can write here, as the width is decreasing, discharge per unit width is going to be increasing. Yes.
Yes, sir.
So now I am giving you the approach flow as subcritical. So directly you go to the UQ curve. Subcritical, is it falling graph or rising graph?
Specific energy is rising, sir.
Not specific energy, my dear. You see,
What?
this is Q curve, na?
Yes, sir. Discharge.
In the subcritical zone, does the graph is representing falling or rising?
Graph is rising, sir.
Hey, think not like this. It's not good. You have to go with the x-axis from here. Now you okay, fine. You see, this is x-axis. Okay, it is increasing. It is x-axis increasing. Then what is happening to y-axis?
Okay, y-axis. Okay, sir.
What is happening to y-axis, my dear? What is
Sir,
happening here?
your voice is not audible, sir, clearly.
Okay. Okay. Now I hope my voice is clear. Clear for you?
Yes. Yes, sir. Yes.
You see, this is discharge curve.
Depth discharge. Right.
And whatever this zone, above zone is going to be subcritical.
Okay, sir.
Because this is YC, right?
Yes, sir. Critical depth.
Now let's take this is Q1 and this depth is going to be Y1. Okay.
Yes, sir.
And if the channel width is going to be decreases, Q2 is going to be increases. Yes or no?
Yes, sir.
When discharge per unit width is going to be increases, now draw a line. And where it is touching, this is Y2. Yes or no?
Yes, sir.
Now you tell me, as a discharge per unit width increases, what is happening to depth?
Discharge as we go on increasing, depth is decreasing, sir.
Yeah, that's it. That's what I have done.
Okay, sir.
Understood or not?
Understood, sir.
Yeah, okay, fine.
Thank you, sir.
Okay. Mr. Suklesh.
Good afternoon, sir.
Good afternoon, Suklesh.
Sir, I have a doubt in previous class, sir.
Yeah,
Sir,
tell me.
yeah, where we discussed about the gender classification. Sir, when okay, sir.
Tell me.
Sir, when we are raising this sluice gate, sir, we have when we are raising this sluice gate in the longitudinal section, you have opened just now, sir. The previous slide. The first diagram, sir. Yeah, this one. Previous slide.
Okay, tell me.
Sir, here in the first diagram, so when we are opening the sluice gate gradually,
okay.
Sir, then will that double spiral movement will be there?
Double spiral movement? No.
Will not be there.
Movement is due to secondary currents now.
Yeah, due to secondary currents.
But we don't consider the secondary currents, right? I told you in the starting itself, we neglect the secondary currents, but the effect of secondary currents makes the velocity distribution non-uniform, okay?
Yes, sir.
But whatever the velocity we take, is it a secondary velocity or primary velocity?
No, sir, it's primary.
So that's it. We don't see, only at that starting point only I said secondary currents. And
Okay.
did not include any secondary currents, right? So
Yeah.
worry about the double spiral.
Yeah, I was just asking, sir.
The double spiral will create, then definitely when it opens, see this figure, when it enters, then definitely double spiral will create over here, okay?
Okay.
But you don't need to worry about that effect.
Okay, sir. Sir, in trapezoidal also this double spiral will be creating, no, sir?
Yes. In all the chance it is going to be happen with respect to the bicyclics.
Okay, sir. Thank you. That's my doubt.
Mr. Balaji, please speak out. Mr. Balaji. Hello? Hello?
Can you hear me, sir?
Yeah.
Sir, my one of the person asked before that. So while considering the discharge and the another specific energy curve, sir.
Yeah.
So we move on to discharge because of the reduction in the width.
Yes.
So if the both combinations are come across in a single scenario, the both curves will be merged.
Very good question. Such type of things cannot be analyzed manually or theoretically. They have to do experimentally. That is known as double transition.
Okay, sir. It will come.
And we don't need to cover the double transition also, because double transition is highly complex in nature.
Okay, sir. Okay, sir. Thank you, sir.
Mr. Kaushik. Mr. Kaushik, speak out.
Hello, sir. Good afternoon, sir.
Good afternoon, Kaushik Bodige. How are you?
Fine, sir. Fine. Sir, sir, if we are considering a section, longitudinal section of a canal,
Okay.
when we are considering such section, if the width of the channel increases, then what happens to the Q, sir, small q value?
If discharge width increases, then small q value decreases.
Does it depend on the type of flow, sir?
No, we are discussing about steady flows only. We are not discussing about unsteady flows, right?
Okay. Means we are considering only channel reduction, no, sir? Means with width reduction. Why are we considering the width increase?
No, we are not only considering the width reduction. We are going to conclude the width expansion also. Whenever there is a change in width, then discharge period width changes. Okay, whether it is width reduction or expansion. But for us, the reduction case is going to be much more important. Why? I'll tell you later, tomorrow's class.
Okay, sir. One more case. If the width of the section is increasing and the channel bed depth is increasing, then what is the case, sir?
So that's a double transition case. That's a highly complex in nature. We cannot predict the behavior manually or theoretically. We have to do it by means of experiments only. Okay. That way, we are solving the question.
Sir, one more doubt. One more conclusion I have made, sir, while practicing. When the depth of the depth of the bed is increasing and width of the section of the longitudinal section of the canal is decreasing.
That's what, my dear. I'm saying is those are nothing but double transitions. Okay.
Okay, sir.
You are saying is there is a change in the bed width, there is a change in the local bed, channel bottom. So conditions are double transitions, means both the transitions are going to be seen. Width the transition is there, channel bed transition is there. Those are highly complex in nature, and those things we are not going to analyze manually. Okay.
Okay, sir.
Those things can be solved by those things can be solved by numerical analysis. We can solve, but there is no theoretical analysis. Whenever we do channel transitions, no, we always assume only one transition at a time. For example, if there is a width transition, if I say width reduction or width expansion, I have to keep the channel bottom as horizontal. Okay.
Okay, sir.
And if we discuss about the channel bed rise or channel bed drop, we have to make sure the width should be constant. So both cannot happen at the same time while we are doing the theoretical analysis. And that theoretical analysis is highly complex, and it's not important. Forget about the important. Even in your MTech course, you don't go further.
Okay, sir.
If you are going to go for the PhD, then only you can think about that. Okay.
Okay, sir.
Yeah.
Thank you, sir.
Yeah. Next, Mr. Sriram Verma. Mr. Sriram Verma, please speak out.
Yes, sir. Good afternoon, sir.
Sriram, tell me. Good afternoon.
Sir, I had doubt in width transition, sir.
Tell me, what's your doubt?
Sir, why can't we use width transition concept by using specific energy curve?
Very good. If you are using the specific energy curve,
yes, sir,
channel bottom rise. What is the first point in discharge curve? What is
Sir?
the first point in the discharge curve? If you want to use the discharge curve, let me open that. If you want to use the discharge curve, what is the first point? What is its meaning? Are you able to see that?
Yes, sir. Yes.
What is the meaning of that? For a given upstream specific energy, which means the specific has to be constant.
Yes.
Hello?
Yes, sir. Yes, sir.
Yeah, when specific energy is constant, then only you can use the discharge curve. If the channel bed rises, does specific energy is going to be constant?
No, sir.
If channel bed drop, does the specific energy constant?
No, sir.
Then how come we use the discharge curve for a channel bed rise or channel bed drop?
Okay, sir. Like I have a thing like this, sir. This as the bed width decreases, so automatically the cross section will decrease, right, sir?
Cross section decrease, but not about the depth of flow. You cannot say the depth of flow is going to be decreases or increases, right?
Yes, sir. Yes, sir.
Yeah, tell me, I'm listening.
As cross section decreases, then we have this thing. Velocity will definitely increase, right, sir?
So that's what my idea. What is the area of rectangle?
Hello.
Area of rectangle, tell me. What is the formula for area of rectangle?
Length of the breadth, sir. Yes.
So you are saying width is reduced.
Yes, sir.
If you okay fine, you reduce the width. I'll increase the width. I'll increase the depth. You reduce the width. I increase the depth so that I keep the area constant. Is it not possible?
Yes, sir. It is possible.
If that is going to be possible, velocity is going to be constant, right?
Okay.
If area is constant, then velocity is also going to be constant. That's what continuity says. Q is equals to A1 V1 is equals to A2 V2. Yes.
Yes, sir.
So those things are not just as it seems. It requires a huge analysis. Just for we see the open channel flow, but we cannot see as it actually is.
Yes, sir. Yes.
Just because of you reduce the width, our cross-section area is going to be decreases. No, it's not like that. When cross-section area decreases, you reduce width, fine. But if the same time depth also decreasing, na, width decrease, depth decrease, then area will decrease. Okay.
Yes, sir. Okay.
Okay, fine. That's it. So, Mr. Sandeep Kumar came and you went out. Okay, fine. I hope these are the things for today's class. Hope you people are able to understand. Hope so. Getting some problem regarding to this. So I don't know. Suddenly my whiteboard, whatever the screen I am using, it got stuck. So okay, fine. So I hope you go through the notes once again, and we can see the things remaining things are tomorrow. Yeah. Have a good day for you, and enjoy the Sunday. We'll meet tomorrow. Same timing, 7 to 10.